several different names, but the BOD5, which has to do with the 5-day test, but we'll just talk about the biological oxygen demand here. And the slide indicates it's the difference between the initial oxygen level of a sample and the level after a specified period of time. Normally, we're going to take this, at the effluent, at the effluent end of the system, whether it be a septic tank system or either a wastewater treatment system after a specified period of treatment has been done. So I guess in a nutshell, the way to understand it is it's the amount of oxygen it takes to break down the sewage. If we have a higher BOD, it's going to tell us we have a higher or a stronger type of wastewater, and it's going to take more energy and more treatment processes to break it down. We got the chat box over there too. If you have any questions, I'll try to answer them. And if you'll keep me updated on time, Michael, also. So some of the key information you need to know for the exam is, the basic principles for municipal wastewater. We'll talk about that for, central sewage treatment systems. The important pollutants, contaminants to know about are what we just talked about, the BOD. Also, the total suspended solids are also, considered the TSS, the abbreviation for that. Nitrogen, again, nitrogen is one of the nutrients. Phosphorus is another one, but nitrogen is key. We know that, from springs issues here in Florida and really across the entire United States with, nitrogen reducing standards, laws, and that are being put into place to reduce the nitrogen, which has many detrimental effects. Oils also. Oils are a big thing in municipal wastewater treatment plants, also in septic tank systems, commercial septic tank systems, but especially in municipal wastewater treatment systems, from restaurants and commercial businesses and all that, to ensure that these oils, literally oils, greases, and fats, do not get into the system in a large manner because they'll disrupt the processes. Very expensive treatment, chemicals, and so forth. So that's why a lot of municipalities have stringent guidelines as to pumping schedules, and all kinds of stuff. Eutrophication of lakes and streams is important too. That's part of the detrimental effects that excessive nitrogen, nutrients, and so forth can cause to lakes and streams, thus increasing the plant growth. What happens with the with the fertilizers, the nutrients, the nitrogen increases the plant growth, the algae, and everything else, which depletes it of oxygen, which in the long term, creates fish kills and everything else. We have a number of lakes, even here in Central Florida and Orange County, Lake Apopka, that's been going through massive restoration because of the the farming activity over the last 50 or 60 years. Biological and physical composition of sewage. What does sewage contain as far as the bacteria, the chemicals, the solids, the physical, and what is the processes to break that down into smaller constituents so that it can be properly treated. And also subsurface sewage treatment systems, which aren't just on-site sewage treatment disposal systems, but there's many different types of treatment systems. Move on to the next slide. Everybody can still hear, I guess, and everything else. Continuing on, land application use and reuse of wastewater. Land application, consists of sludge fields, and even in the on-site program, we have land application where it's applied to the land and or water treatment or sewage treatment plants or the other. Reuse, the reuse of wastewater. There's many different reuses. It can be turned into fertilizer, again, spray irrigation, land application, many different uses. measurement of water quality and pollution, the treatment of the municipal wastewater we talked about, which is divided into, three processes, which are, primary, secondary, and tertiary. Which we'll talk about that more, and we have a couple diagrams here also. And also the design of on-site sewage, on-site subsurface disposal systems, including, the protection of the groundwater. Again, the whole purpose for the proper design and preparation of the system is to ensure that, health and environmental standards are met. That's the whole purpose, as we all know as environmental health professionals. That's why we have environmental health professionals that are doing these type of inspections, rather than building department inspectors, because we're actually focused. We should be focused on the environment, on the protection of health. Additional key information is the role of aerobic and anaerobic microorganisms involved in these treatment systems. Sewage, sludge, and seepage disposal, and also soil characteristics and suitability. If you've worked in the on-site program, which I know a number of y'all have, you have a little advantage to these questions here because you've worked in it. And again, the exam has to do with the process and the information, the theory behind it. Soil characteristics. In soil consists of soil materials, sand, silt, and clay, particle sizes. How does the effluent trickle through? Are there hard pan layers? Is the soil suitable? Does it consist of muck? Does it consist of high water tables that would restrict movement or even, increase pollution if there's not, proper treatment. Soil percolation tests are not necessarily done in Florida, in the on-site sewage treatment disposal system program. They were at one time, but in a lot of states, they rely on soil percolation test for the, the determination of the drain field design. The sizing and so forth. States out west or what have you may have hard pan. They may have rock. They might have clays. So it depends on, how that percolation is. The percolation rates would determine the drain field sizes, in some of those cases. Stream degradation and recovery. What happens when, it all has to do with eutrophication. What happens when streams, rivers, and lakes, and so forth are destroyed, by all these contaminants, and what is the recovery process for that? Again, read the chapter in Salvato, for the additional information for this. Let's see where we are. And as we continue, really our purpose is to have some type of control of the wastewater in the U.S. And we have had many major accomplishments leading to the improvement in public health. I mean, that's why we don't have too many outbreaks, regarding really wastewater and this type of thing, because of the treatment where we have gone. It's extensive. The cost to treat wastewater, what the cost is for a public sewer if you have it at your house, the amount of money you pay per month, and also for, the installation and repair of on-site sewage treatment systems just to protect the public health, which is what we're doing. And of course, if the wastewater is not properly designed and controlled, environmental and health problems can happen. Wastewater treatment plants require, at a certain level, 24-hour supervision. They require multiple tests to make sure that they're following that standard. And also, wastewater discharge control is the most common form of pollution. There's still pollution when you have wastewater treatment plants discharge, and whenever there's some type of upset, natural disaster, breakage, or something, thousands, millions of gallons are disposed of into, the rivers, whatever, lakes, ocean, what have you. So what about management? So management, like I just talked about, especially, with municipal wastewater treatment plants, in the case of that and industrial sources of wastewater, is something important. We need to constantly monitor it. In those situations for municipal wastewater treatment plants, that is a big thing to keep, 24-hour monitoring, testing, and all types of regulations, required by, in Florida, the Department of Environmental Protection, and in other states, their environmental regulation department. For subsurface wastewater treatment, as we kind of talked about before, the first thing we're really looking at as the foundation for treatment, really the first thing we do is, like we talked about, we have to determine, is the soil acceptable? Is it going to be able to handle the amount of wastewater? That's one of the things we're looking at, because again, groundwater pollution is something that also is important that we need to prevent, the groundwater pollution. And I do want to mention the wastewater, the municipal wastewater accounts have the largest amount of wastewater that are produced. So let me back up a minute. So probably 70% of the wastewater, 70 to 80%, is coming from the municipal wastewater systems, and less than 30%, coming from the subsurface systems. However, the subsurface systems sometimes are the only treatment systems available. If there's no wastewater treatment provided in an area from a municipal plant, the only option is, subsurface, whether it be, small islands or, areas way out in the rural. But then we also know there's plenty of on-site wastewater treatment systems in the cities. Right here in the middle of Orlando, areas that really aren't serviced by sanitary sewer. So the registered sanitarian should understand, which is pretty self-explanatory, the basic principles of wastewater treatment. And again, it's a logical thing. It's really simple to understand this. Municipal wastewater management systems produce an effluent that is to recharge groundwater tables or irrigate landscaping or crops. So after the massive amounts, the millions of gallons, is treated, again, it's going to either be directly injected into the ground by a type of well, or either into large holding ponds, or even spray irrigation. So it's going to go back into the ground. It's going to be reused. So it has to be treated, to a certain level, and we need to understand what are the health risks associated with that, and also reclaimed water, which is another a new type of water use in the last 20 to 30 years. So I do advise you do a little Google search on reclaimed water, and again, look in Salvato's book too. There's a couple questions on that too, reclaimed water. So spend some time reviewing that also. So wastewater management affects every other area of environmental health also. The registered sanitarian must understand the interrelationships between water supply and wastewater management. Let me take a look at the chat box over here for a minute. Okay, that wasn't a question for me. So let's continue here. So some of the public health implications and pathogens, diseases that are frequently transmitted, through contaminated water, which are contaminated through wastewater, bacteria, viruses, and so forth, protozoa. You can look into that into more detail. Primary control techniques are treatment and disinfection of potable water supplies and proper collection, treatment, and disposal of wastewater. In continuing, sanitation problems are concerned with the adequacy and maintenance of collection and treatment systems. That's when we talked about the management issue of these treatment systems, these municipal treatment systems, and also the collection systems, the sewer treatment systems and the sewer lines under the ground, making sure they're maintained, to keep them free from leaks. A lot of cities have old systems, 50, 60 years old. They allow for a certain percentage of sewage that leaks into the groundwater. So maintenance is very important. Failure of the on-site systems or septic tank systems is also related to poor design, you know what I mean, and poor installation, and also owner abuse. If you work in the on-site program, you're very familiar with complaints and failing systems and the evaluation of those failing systems, and also, abuse would include. I can't even talk straight. I need to drink water. Would include, high water usage, even putting too much, like we spoke of, fats, oils, and greases, using the garbage disposal too much, abusing the system. But it's also not always the owner's fault. It could be poor installation, like we talked about. Maybe the soils were not adequate to accept the amount of wastewater, or the drain field was not large enough to accept that. Also, poor design. A low area, storm water draining in that area, an area where it's vehicular traffic. A number of reasons. It's not a cut and dry reason. So that's an important issue. And just like on-site systems, again, municipal wastewater systems may fail if the biological treatment processes are upset by introduction of toxic waste, which would kill the bacteriological action. Even septic tank sludge could also upset municipal systems that are not set up for that. The large amount of biologicals that are put into that, and also increased flow rates. In times of storms, storm events, hurricanes, what have you, that's going to upset the systems also, the biological treatment. Contamination. What is contamination? Well, does it make you sick? Will drinking it make you sick? It refers to the extent that a health hazard exists. Pollution. Again, definitions you should know. Pollution refers to the impairment of the quality of water to a degree that it affects the use of the water. Example is there a change in the use of the water? Can you still swim, boat, or fish in the water? If you can't, that's referring to a contamination or pollution. So some of the causes of water pollution are really the three basic classifications are really chemical, physical, and biological. It's, again, self-explanatory: chemical, organic, inorganic chemicals, radioactive materials. Physical, we talked about suspended solids, settling, floating solids, foam, and so forth. If you've been to a wastewater treatment plant, you know what this is. Again, biological is the bacteria, viruses, protozoa, algae, and so forth and so on. And then they're further divided into degradable and non-degradable. And so the examples of degradable pollutants are, again, the organic matter, oils and greases, and etc. And again, the non-degradables would include like chlorinated hydrocarbons, nitrates, maybe detergents, phosphates, and other types of salts, and so forth. So a little more detail about streams, lakes, and other surface waters. So surface waters are affected by nutrients, pollutants, and contaminants in the wastewater. Again, and the end effect is eutrophication. Nutrients, nitrogen, phosphorus, pollutants. We talked about pollutants. Could be wastewater, contaminants and the other contaminants in the wastewater. And kind of the different, basically, let me see how to explain this one here. The levels, I guess I would say the levels of degradation, can't even speak right, degradation is kind of, they go from oligotrophic, mesotrophic, eutrophic. We talked about what eutrophic is. And excuse my language this morning. I don't know what's going on. I'm like, my throat is like super dry. So really I'm going to say the oligotrophic is relatively young water, lakes, rivers, or whatever with high dissolved oxygen and low nutrient levels. That's your clean. Those are your super clean lakes. I did a study once for some of the cleanest lakes in the world, and I think one of them was in Norway. But normally cold water is going to be cleaner water too. So really it's low nutrient is the good water, and then we kind of move on to mesotrophic. It's getting a little more, not as clean, and then you go to eutrophic, high nutrient levels like a Lake Apopka in Orange County, more dissolved organics and inorganics, decaying organic matter, lower dissolved oxygen, kind of the trend if things aren't really, if they're polluted. That's what pollutants cause. So a little bit about, subsurface systems, on-site sewage disposal systems. Again, this is a state, really, a national test, so you're probably not going to see the word OSTDS or what have you. You might see wastewater, on-site wastewater systems. There's going to be all different terms, but that's what we're referring to, like a septic tank system. So remember, on-site disposal system, septic system, it's similar, and there's many other terms also. But it's a system that must be designed to properly treat wastewater. Again, there's questions too, that we need to ask, basically regarding that. Will the soil absorb the sewage effluent? We've already talked about that, a couple times. Will the groundwater table level affect the treatment or become contaminated by the sewage effluent? And then will the system create a public nuisance? So some of the questions on the exam could be theoretical or philosophical with these type of reasonings, where they would mean multiple choice, and you would have to determine, will the groundwater table affect the treatment, or will a nuisance be created by this reason? So it's a matter of, thinking into this. The soil, the type of soil. What type of soil is it? We use the NRCS methods. Engineers use other types of soil methods. The soils are different throughout the whole United States. Sometimes they're divided into soil type 1, 2, 3, 4, and 5. And also we talked about the percolation test. So remember that also. The percolation test will also tell us if the soil can absorb the soil nutrient. And also, will the soil filter out microorganisms, or will it let the effluent pass through too quickly, for those microorganisms? If we have a coarse sand or some type of real coarse soil, will the nutrients directly pass through it? Will there be proper treatment? Probably not. That's why we need to, evaluate these type soils and make sure we have the correct one. How will it work? How does it work? Really, sewage flows into the tank. In a nutshell, what solids settle to the bottom through the anaerobic digestion, and all the fats, oils, scums, and greases, all the floatables, float to the top. And that's part of aerobic digestion. And then the effluent is going to flow out into the drain field absorption area, or even seepage pits, in other states, and percolate to the soil. They also have a couple questions. There might be one or two on sand filters, which we don't see too many of them here in Florida. There might be some that were permitted years ago that we're still monitoring. But again, there's different types of sand filters, open or intermittent. Some of them are buried and then recirculating. And combination of biochemical decomposition with physical filtration and absorption. Again, we talked about in the beginning of the presentation, not sure how much time we have, but all the wastewater is actually produced in the home or the business, in this case it's the home, and then it's being disposed of into the on-site wastewater system, which normally would go through a septic tank or treatment tank, and then into some type of absorption bed, leach field, drain field, what have you, and be treated, as you see underneath the drain field, effluent absorption purification, prior to entering into the groundwater. Again, different states, municipalities, townships have different regulations as to the depth to the groundwater, and also the size of the treatment tanks and the size of the drain fields, mainly based on research and science, and again using the EPA model code as the foundation, as here in Florida. Some additional information on subsurface systems is really when we talk about the contaminants, which we kind of carried on a little bit, which are really, we're concerned with the pathogens. We talk about also fecal coliform, which is the indicator of of pathogens and so forth. But normally these are reduced in septic systems, by 99% if they have adequate, area between the bottom of the drain field and the water table. It's quote called the VADOS zone, is the scientific VADOSE zone is what that's called, or the unsaturated soil zone. So septic tank systems, that's why there's what, 30%, 20-30% in the U.S. They work so well at removing these pathogens. Again, 99.9% is what all the studies show. However, they don't do so good of a job at nitrogen. So that's why we have nitrogen-reducing systems and so forth. Again, some of the health effects of nitrogen are blue baby syndrome. Basically, when the level of nitrogen is above the drinking water standard of 10 milligrams per liter, this syndrome can happen. Again, it's normally even higher than that. The studies or investigations have shown above 30, 40 milligrams per liter, and it's normally when you're on a well that has been contaminated, by wastewater, and you're drinking that, especially children or infants, where they're drinking their milk is mixed in with that water, or they're drinking that water, what have you. Environmental effects also of nitrogen, we talked about our eutrophication, know that. Phosphorus, also environmental effects. Toxic organics come from household cleaning agents and chemicals, and again, most of them are removed from the general system. We don't see a main problem. Tanks, again, treatment tanks. I don't know if the exam goes into detail about the tank, but know that the tank has to be watertight and sealed. It has to prevent seepage, of the sewage out of it. It has to contain everything until it goes to the drain field, and it's really designed, as a primary treatment to separate the solids from the liquids. You can see the sludge, the effluent, and then the scum layers. That's the primary job, to filter that out to a primary degree, to an initial degree, so that the liquids can enter into the drain field, and then, final treatment can happen. Rather than also the standard system, we have advanced systems also, and I guess the word aerobic treatment unit is something to remember also. basically it's another degree up, like a secondary type of treatment, because of the aerobic bacteria they're introduced through air blowers. So you might want to, study that a little bit more too. Drain fields, we've talked about leach fields, absorption fields, drain fields. Up at the top right of the slide, you can see this is a repair of a system, I think. The existing septic tank, again, which should be watertight and contained, it's going to separate the solids and the liquids, and then the liquids are going to trickle into this drain field. And if the drain field is not designed properly, it'll have, the soil will properly, absorb the water and filtrate it before it enters into the groundwater table, to ensure that it's effective at removing, the large number of pathogens that we talked about. Covering a little bit about the municipal wastewater treatment process, got a couple slides left. It's really divided into primary, secondary, and tertiary treatment for municipal wastewater processes. Now, we also have that to compare it to the septic tank system. The regular septic tank system is primary treatment. As I mentioned, the aerobic treatment unit would be a method of secondary treatment. Advanced performance-based treatment system for septic would be tertiary treatment. Okay, but we're moving on to wastewater treatment. So primary treatment in wastewater treatment plants really consist of, bar screens. They're going to remove a lot of the large objects that are, that go through the drains and so forth to keep them from entering into the system. Grit chambers, they remove a lot of the sand and the harder particles, stones, and all that settle to the bottom. Then they go into settling, or they're called sedimentation tanks, where similar to the septic tank, where the solids are going to settle to the bottom, they're going to form sludge. In this primary treatment process, about 40% of the BOD is removed. And also, in the septic tank, there's a large portion of the BOD that's removed also. In general, probably about the same. Secondary treatment, which is more of a, let's go back. So primary treatment is physical. It's important to remember that. Secondary treatment is biological, so it's going to remove the additional amount of BOD, whatever's remaining, 45 to 50%. This consists of trickling filters, depending on the type of treatment plant, bed of stones, where sewage is sprayed and allowed to trickle. The microorganisms attached to the surface area on the stones, and they consume the nutrients. And similar in advanced septic tank treatment systems, they also have types of filters and stones which do the same thing, but on a smaller level. Bart, you have 15 minutes. Okay, slides are not moving. I'm stuck on slide 15. Really? Okay. Is everybody? I'm actually on slide 23. So y'all are only seeing slide 15. Working for me, I'm on 23. Okay, well, that's great. Okay, so we'll continue on. So the activated sludge process, I see 23. Okay, great. Aerobic bacteria degrade sludge that is fed into aeration tanks and recycled. Now, I will make a little comment here. We've used these slides for years. I know they do look a little boring. We probably need to add some pictures into them. So I did add a few pictures. So we're trying to make it a little more or less boring. I hope y'all have a cup of coffee with you. Municipal wastewater treatment processes. So the tertiary treatment, let's think of chemical, okay? So BOD, the nutrient and salt reduction. We're going to be looking for reductions, continued reductions of that, accomplished by chemical coagulation, with lime. Again, different chemicals, lime, alum, or iron salts. Flocculation tanks allow smaller suspended solids to flow into larger particles that will settle. And then also the smaller particles are trapped when the effluent is filtered. Let me back up here. Let's see. Tertiary. Continuing with tertiary treatment. Tertiary treated water is considered by many to be the same quality as drinking water. And why is that? That's because disinfection follows the tertiary process. The effluent is chlorinated. It may not look perfect. I mean, it is filtered and so forth. But a lot of times this is drinkable. All chlorinated wastewater must be dechlorinated before it can be discharged from a wastewater treatment plant. Again, normally it's going to be discharged, into spray irrigation, sometimes even into streams and rivers, or injected into the ground. We want to dechlorinate it because of the effects of chlorine that could have onto the environment. So here's a picture of the municipal wastewater treatment plant. A general picture, kind of what we've been talking about. The left, you see primary treatment, basically, in a nutshell, raw sewage. You've got your screens, your physical treatment, and so forth to remove all the grit. And the grit and all that, the solids are disposed of, into a landfill. They have to be removed from the system. That's why a municipal wastewater treatment plant requires a lot of management. There's a lot of work that has to be done to keep it working, unlike a septic system. I mean, they last for years. They do have to pump them on a regular basis, but they don't require as much maintenance, a conventional treatment system. And then you move into secondary treatment. You're going to have the aeration tank and air compressors, blowers in there, and again, there's going to be additional sludge also built up, and that's going to have to be removed too, because the primary treatment is really removing, I guess you'd say, I don't know if you could call them large suspended solids and products and all that get stuck in there. It's going to kind of clean it out in a sense, kind of like a cleaning chamber. And then the secondary treatment, the sludge is going to be at the bottom. There's going to be a lot of bacterial action and stuff happening, and then that sludge is eventually going to have to be disposed of, because again you're running millions of gallons through this. Thirdly, we're going into the tertiary treatment if needed, and again we're going to have disinfectants, chlorine and all that, or whatever the disinfectant is, to kill the bacteria, because again this is only going to take care of a certain percentage of the bacteria, but the chlorine is going to go ahead and hopefully take care of, the higher percentage. Other methods are land application. We talked about it a little. Again, there's going to be some type of pre-treatment before land application, irrigation, application of secondary treated effluent to land or crops, and that includes spray irrigation. There's also rapid infiltration. Large amounts of water percolate through the groundwater table. This is after, again, secondary treatment. It's sent into very large, they look like ponds. You've probably seen them before. Those are percolation ponds. Overland flow, I don't think we necessarily have that here in Florida. We do have constructed wetlands, which maybe that would be considered the same thing, where it is treated, I think maybe higher than secondary, well actually to secondary, and then it is disposed of into a wetland. There's numerous ones of these in Florida. One of them is called the, I'm trying to think of the name, Orlando Wetlands Park. I think you might want to look that up. It's millions of gallons of water, and then it eventually discharges into the St. Johns River because it's been, clarified that much through the constructed wetlands. Best used with clay-type soils with limited absorption capacity. Again, because you don't want the water to the sewage or the effluent to seep down. You want it to have enough time for decomposition. So possible questions that we might have to think of are, and we've really discussed them, biological and physical composition of sewage. We've discussed that. What does it contain? Solids, fats, oils, greases, and what? many types of bacteria, viruses, and so forth. Number 2, disease-causing microorganisms. We talked about that, and toxic chemicals, the bacteria, viruses, and so forth. Industrial waste. What are the common problems? I mean, toxic, they're going to, upset the treatment process. They're going to kill the bacteria. Those are some of the things there. They should not enter into a normal wastewater treatment system. Again, it's thinking of the process. Land use issues in relation to wastewater management systems. The type of land, the type of soil. Is the type of soil going to work for treatment? Will it accept the percolation rate? Does it consist of rock, coarse sands, or what? And also the management of the systems. Are they being managed properly? If they're not being managed properly, then they're going to cause pollution, or they could cause pollution. And again, textural characteristics, the texture. The sand, silt, and clay is what soil consists of. The structure of the soil also. A little bit about soil science, so study up on that. Perform a site evaluation, including a soil analysis. What is a site evaluation? Typically, they're going to talk about percolation tests. What is a percolation test? I didn't go into specifically what that is, but do a little Google on that, percolation test. Again, it's the amount of water that is received into the soil over a certain period of time. And that's how, the drain field sizes are determined and all that. I mean, we did use percolation tests here in Florida over 30 years ago. Processes used in municipal wastewater treatment management systems. The processes. We talked about the processes, primary, secondary, tertiary treatment, kind of understand what that is. Again, small sewage treatment systems, septic tanks, drain fields, what do they consist of? What do they do? Are they simple? Do they have to be managed? Do they require maintenance? Some of the questions you'll need to think about. Prefabricated wastewater treatment systems. What are they? Are these preset wastewater treatment systems? They could be aerobic treatment units. I'm not sure exactly what they're talking about there, but aerobic treatment units and so forth. And remember sand filters. Also remember sand filters, what they do. We talked about stream classifications and wastewater discharge standards. In addition, we talked about, nitrogen, eutrophication, how large amounts of untreated wastewater would affect streams, rivers, and lakes, and so forth. Assist in developing wastewater reclamation and disposal program. Again, a lot of it's theory. It's thinking of the processes. After you've learned this, the registered sanitarian is not just the person that's going to do a cookie-cutter job by designing a system or just going out and doing an inspection. And, it's also going to be thinking, how do I assist? How do I make a recommendation? And how do we make this better? It's really taking it to another level. That's really what the environmental professional is. I think I'm about done. Let's see if we had another slide. Any questions?
Morning, everybody. As you can see, I retired last year from the Department of Health as the Radiation Safety Officer, so I'm going to go through the slides and hopefully they'll cover what you'll need to know on the test. So we're going to talk about radiation terminology, cover the different types of radiation, incident response, and lastly, terrorist attack. So what is an atom? The smallest part of an element that retains the properties of the element. Atoms are made up of protons, neutrons, and electrons. They make up the elements, and elements make up matter. There's a diagram of a atom. We have protons with a positive charge. They determine the element's identity. Neutrons, neutral charge, determine the nuclear properties. And electrons, they have a negative charge and determine the chemical properties. There's a periodic table from your high school chemistry. I'm sure everybody remembers that. There's 117 elements, with 92 occurring naturally. The others are man-made. There's a close-up of the different elements, starting off with hydrogen with 1 proton. Ra is radium with 88 protons. The difference being made up to 226 with neutrons. There's nuclide notation. That's iodine 131. That's used commonly for medical purposes. There's 53 protons and 131 total of protons and neutrons. Isotopes are atoms of the same element with different numbers of neutrons. And as you can see, there's carbon, many different isotopes. Carbon-14 is what's used for dating. Think of radiation as energy. It can be a form of particles or electromagnetic waves. The reason that there are radioactive substances is the proton to neutron ratio. There's 2 types of radiation, ionizing and non-ionizing. They can be either natural or man-made. So what is ionization? Simply the removal of an electron from an atom. There's the electromagnetic spectrum. In general, we're worried about ionizing radiation, particularly with the Preparedness Committee that I co-chair. X-rays and gamma rays are actually the same thing. The only difference is where they originate. X-rays originate in the orbit of the atom, where gamma rays are from the nucleus. All the other types of non-ionizing radiation you see there, from radio waves to UV. So the effects of ionizing can damage to the DNA. You can mutate or kill cells, or ionize the water in the body. And H2O2, that's hydrogen peroxide, something you probably have in your medicine cabinet. Obviously, though, when it's in the body, it's not a good thing to have. There's DNA damage. You can have repair or a mutation with the formation of cancer, or if it's not repaired, you have cellular death. Generally, the higher the dose and the more acute the dose, there's more cellular death. It also does take quite a while for a mutation in cancer to develop. It's generally in the order of 10 to 20 years. So dividing cells are the most radiosensitive. This was discovered by a couple of French scientists, Bergeny and Tribondeau. Some of the examples are the fetus, intestinal lining, blood-forming cells. That's why when we go into the hospital, if you're a female, one of the questions they should be asking if you're going to get x-rays is, are you pregnant or might you be? Especially during the first trimester. There's the different types of ionizing radiation. We have alpha particles, which are 2 protons and 2 neutrons. Beta particles, they're an electron essentially. We have gamma rays and X-rays, and neutrons. Neutrons are much more biologically damaging. The faster the neutrons, the more biological damaging. In general, they're about 10 times as damaging as X and gamma rays. Alpha radiation is relatively a large particle. Only travels roughly about a centimeter in air, and you can shield it by the dead skin or piece of paper. If a hazmat, firefighter, etc., is contaminated, but it's on his clothes, it's not a problem unless it somehow becomes ingested or inhaled. Theta radiation, again, small fast particle. Again, there are electrons. The travel varies quite a bit. Tritium, hydrogen-3, only travel about a centimeter in air. It has a 19,000 electron volt, whereas P32, one of the most energetic beta emitters, will travel about 12 feet in air. But the difference is it's about 1700 kilovolt. Again, you can shield them by thick plastic or thin metal. Plastic is more optimum. You can have something called Bremsstrahlung, which means breaking radiation form when an electron hits a metal surface. Gamma radiation, again, they can be in forms of waves, travel hundreds of feet. We generally shield by lead, concrete, or even thick soil. That's why sometimes linear accelerators, like when I worked at Florida State University, our 3 linear accelerators were all underground. Neutron radiation, again, is fast moving, travel approximately a half mile, and they're generally shielded by water or polyethylene plastic with a combination sometimes of the plastic and lead. There is shielding again. To remind you, alpha can be shielded by paper or even your skin. Beta stopped by aluminum or plastic, roughly about a half inch to an inch of plastic. Gamma and neutron, depending on the energy of the gamma ray or the neutron flux, would depend on how much concrete or water you would need. Radiation measurements. Rankine is equal to a radiation absorbed dose is equal to REM, Rankine equivalent to man. There are international units, sieverts and grays, but those are used, fortunately, in other countries, not in the U.S. A sievert is 100 rads. So, how much material is there? We don't use weights or volumes or mass. We talk about activity, and you can see 1 gram of the different isotopes equals a lot different amount of the activity, and that's related to the half-life of the material. And again, half-life, radiation decays, and it takes quite a bit of difference in time. Technetium-99m, you see, is 6 hours. That's the most common isotope used in nuclear medicine, and it's optimum because of 2 main reasons. One is the energy level is about the same as X-rays, and the other is that it's a short half-life. After about 10 half-lives, radioactive material is essentially stable. After 7 half-lives, there's only about 1% left. Thallium-201 is used primarily, again, in nuclear med, heart scans. Cobalt-60 and cesium-137 are industrial isotopes. Probably 2 of the most highly isotopes that would be used for a dirty bomb. And again, Americium-241, you may have one in your smoke detector at home. However, they only usually are about 1 microcurie, which is a very small amount of radiation. Sorry, I'm not sure what's happened. I've lost control of the screen.
I'm going to take it back from you and then give you back. Oh,
Okay.
So you got it?
No, it's still not advancing the slides.
Move your mouse to the left. That's working. Or, it's your PowerPoint. Hit escape. Okay. And try to do the from this slide.
There we go. Alrighty, we'll continue with dose rate units. The mu is a micro. That's 10 to the minus 6. Milli is 10 to the minus third, and then R per hour. Generally, we're not worried about micro R per hour readings. One of the main things when we have a law enforcement in the field that detects radiation is that they keep the units correctly, because there's a big difference between micro and milli, obviously 1,000 times difference. Key concepts: exposure or dose rate. Think of exposure, or think of dose rate as the radiation received over a time period, like a speedometer, or the dose. So that's the total amount of radiation received. Effects of the acute exposures. It generally takes about 50 to 75 rads before you'll see any effects. And the first effects that are detectable internally is if your lymphocyte count goes down. Again, 100 rads, you'll start having some vomiting, diarrhea, etc. Generally around 500 rads is a lethal dose as an acute dose. And some of the limits. 2 MR per hour, milliroentgens per hour, is the limit to the general public. That's where your hazmat teams will set up their control zones. We practice this on Wednesday. I provided radiation training to various law enforcement agencies, the National Guard, the FBI. Different agencies do have different turnback values. The BRC, that's part of the Department of Health's Bureau of Radiation Control, their turnback value is 5R per hour. As a radiation worker, you're allowed 5 rads per year. It's been my experience. Most people that work special procedures in hospitals, such as cardiologists, just about run their limit. As a radiation worker, when I was with the Bureau of Radiation Control, I probably averaged about 1 rad per year. My lifetime dose is probably around 20 rads. As you can see, 25R, that would be volunteers only. Estimated exposure to the population is about a half rad per year. That's equivalent to about 50 chest x-rays. And that would be from naturally occurring radioactive material. There's the natural series of uranium and thorium in building materials, ground, soil, etc. And then, of course, medical x-rays. And most people will say, why do smokers receive radiation generally about 1.3 rads per year? The tobacco contains polonium-210, which is a naturally occurring radioactive material, and it absorbs into the tobacco plant and hence then into your lungs. That's one of the reasons that it causes lung cancer as well as other carcinogens in tobacco. There we have some typical doses. Dental and chest x-rays are about the least, about 10 millirem per year. Nuclear power plants, 0.1 millirem per year. As you can see, very little exposure. Most of you have heard about 3 Mile Island. Most of the general public that was closest to the power plant only received about 10 millirem whole body. Again, I explained the smoking. You may ask, why do I get 5 millirem on a airplane ticket trip from coast to coast? That's because you're above the atmosphere that protects you from cosmic rays. Radiation sources, naturally occurring, as I mentioned, soil, building materials, cosmic radiation, food and drink. Picture of bananas. Always interesting. There's potassium-40 in bananas. But I would recommend go ahead and eat the bananas. They are healthy. There's only nanocurie to picocurie quantities of radiation in the bananas, so no troubles. However, with our detectors that we carry as far as the preventative rad nuke team in the Tampa Bay region, if somebody did have a load of bananas on a truck, we would be able to detect the radioactive potassium. Nuclear medicine, of course, nuclear power. Consumer products, there's your smoke detector with americium-241. That's a picture of a moisture density gauge in the lower right. They're used on checking roadbed material to see if the material has been put down in a proper manner and the right density. Nuclear medicine, you can see somebody's being injected. Just of interest, they generally inject about 10 to 20 millicuries of radioactive material into you. Contamination. That's where we have rad material in an undesirable location. Generally, the most common thing is to track it on your feet. There we have what's termed a lead pig with an isotope, probably Tech 99M in it. It's lead lined, and those are shipped commonly by FedEx. You can see there's a 55-gallon drum emitting radiation. Those are shipped to your burial sites. Giving it a cost estimate, when I was shipping radioactive material from universities back in the 80s and 90s, it would generally cost about $1,000 a drum. And again, that was 30 plus years ago. And there at the bottom you see a transportation accident. Decon, most common things we tell our hazmat teams is that it removes roughly about 80% of the material if you just remove people's clothing. You don't want to use a wire brush because that abrades the skin and can allow the radioactive material to directly enter to the bloodstream. You would use tape if you're trying to get particles off of somebody. Again, soap and water is the best choice. Concept known as ALARA is very important. You want to minimize your time, increase your distance, and increase your shielding to try to minimize your radiation dose. Common joke among hazmat folks is to try to stay behind your buddy. The inverse square law, the radiation drops off logarithmically as you move away. So again, if you can just take a step or two back from the source, you can reduce your radiation by quite a bit. We'll talk about some incidents now. Transportation. Responding to the incident, you try to stay upwind, although it's generally radiation accident. The radiation is not airborne. Of course, you'd want to stay as far away as possible, depending on the size of the amount of activity of the spill. Of course, you want to protect the general population and then restore property, etc. There's your zones. As I mentioned, hazmat would set up a 2 MR per hour line, being downwind. Transportation accidents. Fortunately, radioactive material is highly regulated, and accidents are relatively few and far between. As I said, medical isotopes are on our highways, streets, etc. every day. The soil density gauges, they're out on our highways, etc. DOT has quite a few of them. According to the Bureau of Rad, there's several lost every year in the state of Florida. Low-level waste shipments, nuclear fuel rods, they're relatively rare. When we do have a shipment to a power plant, they are undercover and highly protected. That's a type B shipment that's used for the fuel rods. There's a box, looks like an ammo box. Those are commonly used to put radioactive material in. And there's a small lead pick with a medical isotope. Packaging, you have 4 different types. Accepted is something like a smoke detector would be in. Type A is your medical, and type B is your fuel rods. There's your accepted. Industrial. There's a type A package. Again, usually your medical shipments. And there's a shipment of fuel rods. And or on your lower left, you have a gamma camera that's used in industrial radiography. Much of that takes place in the panhandle out by Pensacola with your industrial lines. Labels, empty. And depending on the amount of radioactivity and dose rate, you have white ones, yellow 2s, and yellow 3s. I don't think you'll be asked the exact dose rates, but the higher the number, the higher the radiation. Shipping papers are required, and they're very detailed. Identity, activity, category, etc. Just a small picture of a shipping paper. Emergency response guide, now you can do those as an app on your phone. Briefly, terrorist attacks. Of course, we have Homeland Security. Radiological attack, a radiation dispersal device. It's much more likely than an improvised nuclear device, but again, it would cause quite a bit of panic, social problems, etc. And then, of course, we have a nuclear detonation. You can see the casualties would be huge. One place in the center of Tampa would actually be devastating. It only takes about 20 pounds of special nuclear material to build a nuclear device. There's our dirty bombs and aerial sprays. Again, probability is much higher with a dispersal device. Different configurations. Dirty bomb, again, is not a nuclear device. Nuclear devices are weapons grade and either enriched uranium or plutonium. Exposure device. Somebody could put one in a trash can and expose the general public. We have experimented in practicing this type of device at the Tampa port in the passenger terminals, obviously when they were vacant. Director of safety of the port is on our radiation team. Naples incident, one of the BRC guys that's now retired actually was there and located a device under a boss's chair. The exposure, though, was relatively low, roughly that of a spine x-ray. Nuclear facilities, they're highly regulated, highly protected. You can see the size of a containment building is very small. When you drive by Crystal River, the building you notice is not the containment building, but part of the coal that's used there for production. Again, very well shielded. They have SWAT teams on their property. Just some examples. Nuclear weapons. Again, we know that Iran has enriched uranium beyond the point of what's needed for energy. Something interesting as far as energy distribution, you can see that much of the energy is not nuclear, but thermal and blast. Again, damage would be very bad to the lungs. Everybody's got an opinion. And the nuclear detonation is Al Qaeda's ultimate goal. You can see that, again, there was nuclear weapons on an airplane here in the U.S. and they didn't even know about it quite a while ago. Alrighty, that concludes the presentation. Thanks and have a good day.
Assuming that is. All right. Well, then I will get moving. I think we got a lot of ground to cover and a fairly short time to cover it, so I will get started. This is potable water review, and we'll start just with a very brief overview. These slides should, if not available now, will be available later, so I'll be skipping over a lot of the details, but they're certainly out there. Here's the definition of potable water. This is right out of the study guide. I mean, basically, it's water that if you drink it, it's not going to kill you or make you sick. Always a good thing. Historically, of course, people, grew up and civilizations grew in areas of abundant water. They knew they needed it, and they knew that if it was bad, bad things were going to happen, although the actual cause and effect were not really well understood. As things got more and more into, got larger, water supplies became contaminated, which brings us to Victorian London, where things were so bad that Parliament was looking to get out of town because it smelled so bad. Now, depending on your point of view, that may be a feature and not a bug, but nonetheless, they passed the first known drinking water law in the Western world, which was the Water Act of 1852, which said that you had to filter any water taken from the Thames River. It worked at reducing the smell and made it taste a little bit better. It also worked at lowering disease quite effectively, and we'll talk a little bit about why. They didn't quite understand why, but hey, it worked. The next big step was chlorination. They've been doing it emergency here and there up to the in the early 1900s, but the first custom-built purpose and utilities really quickly jumped on that because it was cost-effective and efficient, and it absolutely dropped the number of disease incidents quite a bit. It was one of those miracle, ingredients. So moving on, we've gone to chlorine, we've gone to filtration, and then what happens in 1974? The United States government passes the Safe Drinking Water Act, and this was designed to address concerns about, still we had some contamination coming up here and there, and state supervision was not as consistent as they would like. So they set EPA, which was a new agency at the time, as the primary federal agency. They gave the states the option to take responsibility, and all states, I think, but one did so. But the EPA is the one that sets the basic rules, and then the states have to follow those rules or more stringent. Later amendments, we get new stuff, testing for Giardia, Legionella, Cryptosporidium, consumer confidence reports, letting people know what's actually in their water, which is nice, and a state revolving fund to help people, continue compliance as things get more and more technical and difficult. Now, I do want to step back here and just to point out, and something that maybe you'll probably want to remember for this exam, is that the Safe Drinking Water Act only applies to public water systems. And what is the definition of a public water system? It provides water for human consumption to at least 25 people per day, at least 60 days out of the year, or 15 service connections or more, at least 15 service connections. That leaves, things from as small as a single family home up to some small commercial operations not covered under the Safe Drinking Water Act. Now, some states, Florida included, do have laws that cover that, but when you're when you're talking from the RS exam, a public water system is going to be at least 25 people per day. There's a couple types here: the community, which is what most people think of when they think of public water, and then the non-transient and the transient non-communities, and that depends on whether the people don't live there, but are they the same people? And there are the definitions there. Another thing you'll probably want to be aware of is the maximum contaminant level, and that is just the maximum amount of methyl bad stuff that is allowed in the distribution going out to any user of a public water system. So that is one of the big deals that the Safe Drinking Water Act is supposed to do. Now, of course, why do they do that? Well, the primary reason for maximum contaminant level is to control potential health hazards. Historically, that had been gastrointestinal disease. You all should be relatively familiar with most of these. And sewage contamination is, at least historically, the most common cause of these waterborne diseases. And some of these can go very quickly, and they can kill very large numbers of people. So you want to make sure that this stuff's under control. There are other things other than potential pathogens. I'm sorry. Moving on here, I want to talk about indicators. Indicators being that it is not possible to test for every single possible pathogen. We want to do some proxies when we do routine sampling. And of course, the most common group you will see is total coliform. Total coliform tells you whether the system is open to potential contamination in general. The fecal coliform group, and more and more commonly, E. coli specifically, does tell you whether that's fecal contamination that we're dealing with. So another thing you might want to just keep in mind, these are indicators. They're good proxies, but they're easy to test for. They're common. Now, when we talk about bacterial disease, that's the most common concern. We can also have chemical threats to the drinking water. Some of these are acute, and I know nitrate was mentioned earlier, but some of them have long-term chronic effects over a long period of time. And here are just some examples of the contaminants that we are concerned about in the drinking water. Some basic health effects, some more common ones: arsenic, where we have a carcinogen or skin or kidney problems; lead, of course, in the news not too long ago; that affects the nervous system, particularly in developing children. That is a major concern. And nitrates, where we have the methemoglobinemia, and that is an acute issue. So not just bacteriological, now we're starting to look at chemical issues as well. So ideally, we try to keep them out of the water source, but if not, what we don't want to be looking up on is water treatment. And we'll kind of rip through this fairly quickly, but of course the most common one is disinfection. As I said, our biggest worry is bacteriological pathogens. So we want to add a chemical to kill these things. Most common, of course, is chlorine, some form of chlorine, but we also see ozone and UV. Now, at least in the United States, ozone and UV cannot be used by themselves because they don't keep a residual. They don't hang out, but they are very effective against certain critters. I do see a 0.2 part per million residual required under the Safe Drinking Water Act for at least free chlorine. You'll probably want to remember that number. Another treatment, particularly for surface water where they have high particulates, is coagulation and flocculation. You add a coagulant, mix up the water real good, and all these particles join together, they coagulate, and then you let it sit very slowly, and those coagulated particles bind together into floc. From there, you let them set out through sedimentation, either let them fall out or rise to the surface where you can skim them off. Florida is mostly groundwater, but we do have some fairly substantial surface water plants, so you'll see some of these. Filtration, that is a physical process, and it is mandated by the surface water treatment rules. So if you're dealing with a surface water source, you need to filter your water, and there's several ways of doing that. Now, the old one is the slow sand filter. It's very efficient for removal. It actually is pretty good at removing microorganisms because as the thing sits there and it's fairly, the water isn't moving through so fast, you get a thin layer of organics and organisms, basically like a little biofilm on top called the Schmutzdecke. And that's where a lot of the bacteria is filtered out or eaten by other predators or whatnot. Teeny tiny predators, mind, but there they are. It is suitable for small community systems if you have the land. It does take a fair amount of room to set up a slow sand filter, but the technology is pretty much bulletproof, and they still use it today. Here's a fairly simple, cutaway of a slow sand filter. You have the water coming in. And just like I said, here's that Schmutzdecke there on the right on top of the sand bed, and then the filtered water comes out through through perforated pipes down near at the bottom. The next step is the rapid sand filter, which is exactly what it says on the tin. It's a faster filtration rate than slow sand. It doesn't remove microorganisms though, but it is very good at removing that floc after the coagulation and flocculation step. They can be gravity, or you can have a pump on there. Because of the frequent backwashing and all of that, the rapid movement of water, you don't get that Schmutzdecke forming. So like I said, you don't get the removal of, say, pathogenic bacteria particularly effectively, but you are removing larger pieces of stuff out of that water. So it does a pretty decent job depending on what you need it to do. There's also diatomaceous earth filters. I don't know if you've done pool review yet, but you'll certainly be talking about those when you get to pools. Same deal. It's a thin layer of these diatoms, or at least the skeletons of them, sitting on a fabric or metal mesh. Let's see, reverse osmosis. That's a very common one. It is a physical process. It forces water through a semi-permeable membrane. Whereas, say, most of your filtration removes things perhaps at the bacteriological level, this is removing stuff at the molecular level. Downside is it requires very high pressure, and also a downside is it requires disposal of whatever is left over. I mean, those salts and whatever you're pulling out, they don't go away. You have to get rid of them. But it's very useful for lowering TDS, hardness, and removing many inorganic ions. Ion exchange you'll want to know about. Water softener is an ion exchange commonly used. Calcium, magnesium comes out. Also see it sometimes for iron or radium. It's also commonly used. A granular activated carbon, it is a physical and chemical process. Basically, it's used for taking out organic compounds, for taste and odor control, and for controlling dangerous organics. And basically, those organics absorb to the carbon. Aeration you want to know about. It's a physical and chemical process. Mostly in Florida, it's used to remove H2S, but it can also use to be removed other gases, volatiles, or radon. Or to oxidize compounds for later removal. If you have iron issues, you'll probably want to oxidize your water first. So aeration is an important treatment step. And before we move on out of treatment, I'm going to give you a link here. This is the EPA's Readability Database. If you're working in drinking water, you probably should have this on your computer, this link on in your browser somewhere. But it is very, very useful. You can go there, you can search for a particular chemical, and it'll tell you some of the best available technology to get rid of it. Let's see, next thing we want to talk about, or at least maybe know about, is backflow. According to the DEP, it is the undesirable reversal of water flow from non-potable to potable through a cross connection. Basically, if you want the water flowing one direction, you don't want it coming back, that is bad. Probably the takeaway for at least backflow, or at least something that you need to remember, is that there are two types, back siphonage and back pressure, and they are different, and certain gadgets work against one and may not work against the other. Back siphonage is called when there's a vacuum in the potable water line and it's pulling the bad stuff into it through that cross connection. Back pressure is where there is actual pressure in the non-potable fluid and is pushing the methyl ethyl bad stuff into your drinking water. So that is, that's the two things, and we'll talk a little bit. This is just a list. You should be somewhat familiar with these. This is listed from most effective to least effective, or something you want at the highest level of hazard down to the lowest level of hazard. But you'll notice that a pressure vacuum breaker does not work against back pressure. It only works against back siphonage. So be careful when you're looking into backflow prevention devices. Some other ones that are out there, particularly in premise plumbing, dual check valves, hydrostatic loops. Notice which ones work against back pressure and don't work against back pressure. So some of these things you'll want to keep in mind. So that's a lot of the that's a lot of the technology and the treatment issues. Very briefly, we'll talk about the hydrologic cycle. You should be very familiar with this. Water evaporates, it condenses, and it comes back to Earth as precipitation. Sort of the big takeaway for this slide is that you want to know there are two broad categories of water storage. The first one is going to be surface water, water that's open to the atmosphere. There are some advantages and some disadvantages to it. It can easily stored. You can, dig a big, reservoir, dam things up, get a good idea of how much water you have, so you can plan a little bit. When it rains, the water is restored much quicker. Downside is it's much more likely to be contaminated and requires much more extensive treatment, so it's more expensive. And you also lose quite a bit through evaporation. By contrast, groundwater, you don't get a lot of evaporation. The water is naturally filtered. It's much easier to treat groundwater. It's available where you need it. You don't have to take it out of a lake and then pipe it miles and miles and miles and miles. So you don't need as much infrastructure. Disadvantage is it's not nearly as easily replenished. There are some cases where, if you're in a drought, it doesn't matter whether you're in a drought. You want rain 60 miles inland. And it can also be very hard, particularly in areas with limestone aquifers like Florida. And another downside about groundwater is you need to do some work to get to it. You just can't go down and get a bucket. And so what you need is a well, which is an excavation. It can be dug, driven, or drilled, and those are the definitions you'll see in the RS review. A dug well is probably the classic, what you think of in the well from Little House on the Prairie. It's big, it's got bricks around it. They're also sometimes referred to as a bored well. Now, I'm not aware of any in Florida, but they are still used elsewhere in the United States. Downside is they're shallow and very susceptible to contamination just because they're so large. On the plus side, they can obtain water from some less permeable materials because of that large size. And so here's a simple diagram of a bored well. So see, the next one, the next category we will talk about is driven. And that is one where you're driving, typically with like something like a sledgehammer by hand, driving a small diameter pipe with a pointy bit on the end of it down into a shallow water-bearing sand or gravel aquifer. You'll sometimes see it referred to as a sandpoint well. You really can't use it in hard or rocky soil, so you have to, there's very much limits to what you can do with it. They're simple, they're easy, they're economical, they're shallow, and again, because of that shallow, they're easily contaminated. Again, here is a simple little diagram of a driven well. The most common that you see are drilled wells. They can be built either by, using a percussion method or rotary drilling. We won't get into that, but they can go very, very, very deep. They can go through rock. They can go through multiple layers of aquifers. The nice thing about them is you have an annular space and it can be sealed with either neat cement or with a bentonite clay. So that makes them much less susceptible to contamination than other types of wells. So if you see that on the test, a drilled well is the least susceptible to contamination. So that's something that you'll probably want to remember. Again, another little diagram of a drilled well. Briefly, you'll want to know at least what permeability is, which is basically a measurement of how easy it is for water or contamination in that water to move through an aquifer, through the rock or the sediment. And here's a little, graph I got out of a geology textbook online, open textbook, kind of neat. There's a link down there at the bottom. But by and large, the takeaway from this is that your faster movement is going to be through things with bigger holes in it. Gravel, sand, fractured or fissured rock. And then, of course, clay, very tight structure, small pores, igneous rock, metamorphic clays, what have you. You're going to see a lot less movement. So it's going to take a lot longer for contamination to get it from point A to point B. And let's see. I think I got 1 minute left. Last thing I'll touch on then is sampling. This is fairly simple, very straightforward. Some general guidelines. Don't stick your finger in it. Don't contaminate the bottle. In general, you want to flush for a couple of minutes and then reduce the flow before you take the sample. Here's some coliform E. coli samples. Most of this you should know if you're an environmental health specialist and you've done water sampling. It should be second nature. I do want to talk about, just briefly, lead and copper because it's a little bit different. In this case, you're looking for trouble. You're looking for the worst case scenario. So you do not flush the water before you take the sample. Let the water sit for at least 6 hours, preferably longer. So yes, you're looking at a different mindset in this case. So don't fall into the trap. This is just different, at least when you're talking about the Safe Drinking Water Act lead and copper rule. Again, here's another link to a good EPA guidance document. Probably should at least have the link, if not a copy of this, depending on how often you do this. So I think that's what I've got. I know that was a lot of material in a very short period of time. Does anybody have any questions? If not, here's my contact information. If something comes up, by all means, don't hesitate to give me a holler.
Can you see my screen?
Yeah, you're good.
Okay. All right. Good afternoon, everybody, or good morning. Scott Montgomery, Sarasota County Emergency Management. My role in the Emergency Operations Center is Operations Chief, but also Recovery Sections Chief. I've been with Sarasota County 37 years, looking to retire next June at the beginning of hurricane season. So should be pretty interesting. My role in the emergency management office, again, is operations. So anytime we have an activation or we have a incident of any type, it's my responsibility to coordinate with the different entities or agencies that are involved with the incident. And then on the recovery side, that's post-storm. So the debris, road clearing, setting up temporary housing, setting up points of distribution, or we call them NPODs, debris, damage assessment. Those are all my responsibility, but also the reimbursement piece, because when we ask for resources, those things aren't free to county government or any government. So there's some reimbursement that goes along. So what I want to do today is just kind of talk about disaster preparedness. I did go online and try to find some sample test questions for your test, but I could not find any. So as we go along on this presentation, if you have any questions or how it relates that you might see on your test, please let me know, and we'll talk about it. All right, so let's see here. All right. Within the emergency management profession, a lot of folks think that the Emergency Operations Center has everything at the ready. We have a plan somewhere. A lot of times we don't have a plan. And this year, 2020, has really proven to be pretty interesting, of which I think all of you can attest to. We are on day 300 something on this whole COVID response. Who would have thought that emergency management we would be in there? So we've had to come up with some planning. We did have some planning with our local Department of Health, but a lot of things came up that we just weren't sure. Everybody knows the plan. No, that's not true. Sarasota County government, we have a workforce of 2,200 employees, and sometimes those assumptions really aren't true. Hey, you can see that background photo, all those school buses that are in water. Just for a reference, those school buses, that's a picture of New Orleans when Katrina went through. Those school buses were actually supposed to be used to assist in the evacuation of getting the citizens out of New Orleans. However, the emergency manager was not around at the time, so those buses sat. We just wait around till the EOC tells us what to do. That's not really true, because the Emergency Operations Center in emergency management, our job is to coordinate with other agencies to fulfill any missions that come out, including environmental health, having you all assist us in going out and testing things after a storm, such as the gas stations, looking at their pumps and such, and their underground tanks. So that's not really us. We just coordinate with all of you, and we're not really the command, if you will. And then the EOC will take care of that. That's not true either. I mean, the EOC is just a location. It's a facility that allows other agencies, county governments, local governments to come together to get resources. And again, resources under ICS, that is people and equipment. And just for what it's worth, I talked about ICS, that's the Incident Command System. Federal government requires that all governmental agencies be NIMS, National Incident Management System, required. That means that every county government, every city government, federal government, state government has to have NIMS, the National Incident Management System, as part of their day-to-day structure. With that in mind, employees that work in an emergency operations center during times of disasters have to have ICS training, Incident Command System. I'm not sure in your Department of Health areas where you're at with that, but folks that come and work in our emergency operations center, we like to make sure that they have at the basic the ICS 100, 200, 700, 800 and also the 300. Our disaster recovery plan goes something like this. Help. Well, we in emergency management, emergency preparedness, we have to have plans because of, I'm sure some of you have heard the statement. If not, our kind of motto is fail to plan, plan to fail. So we have to have plans. And some of our planning is actually required by state government. Sarasota County, and we're going to cover that here momentarily, but we have to have plans for anything and everything that we would be a man-made or even a natural disaster. 4 phases of emergency management. First is mitigation. Take steps to lessen the impact. Emergency management, we work with all of our agencies, and this is actually nationwide, to come up with local mitigation strategies. And a mitigation strategy is basically look at areas of your community that are prone to being repetitive disasters or repetitive losses during disasters, and let's fix those things. There's actually federal grants set aside for municipalities to use to identify those types of impacted areas and fix them so they're not damaged per se. Preparation. Emergency management, folks always think, well, we only, work during the hurricane season. Well, that's not true. Our roles are pretty much 12 months out of the year, so we have to have plans in place. We have to have supplies ready. We have to have contracts in place, and that's really the big one. And we talked about, or I talked about originally about, or at the outset about reimbursement. These things take time and they cost money. So just for instance, Hurricane Irma that affected Sarasota County, we had about $13 million worth of damage from that little storm. I mean, it wasn't even a hurricane per se when it passed through us, but it's money, and we have to go through processes to hopefully get our money back. And then the response. That's where Sarasota and all other counties and municipalities, again, we have to have types of plans in place, and how are we going to respond to that disaster or that emergency. Right now, we're dealing with COVID, but right now, we actually just got off of a meeting. Our next response that we have to work with is the vaccine that's coming out for the public for the COVID. So it's going to be in different tiers, first responders, and then healthcare workers, first responders, and then to the general public. So we're currently in planning stages on how are we going to do that and what does that look like, but also under the incident command system, who's going to take the lead and who's going to help out with that. And then lastly is the recovery. Sarasota County government, we were the first emergency management in the state to have a recovery section, and recovery is usually the most costly for governments post-storm, and out of that, the debris, picking up debris is always the government's most expensive. So again, the recovery section is basically looking at, what do we need to do to get our community back in place? How do we help our citizens? But more importantly, I shouldn't say more importantly, but getting our government and our infrastructure back up and running as quickly as we can. All right, some preparedness and response tools that county governments or emergency management should have is the first is the county CEMP, that stands for continuity of, the CEMP stands for the Emergency Management Plan. What does your plan look like for both man-made and natural disasters? And we have to have plans for anything and everything. And some of you may remember we had an incident out in the Gulf of Mexico in 2010 called the BP oil spill. We didn't have a plan for that, but we did create the plan. What are we going to do if oil washes up on our shoreline? Oil gets into the bays and into the mangroves. We worked real well with our local health department and environmental protection agency on developing that plan. The CEMP, again, every county has to have that plan. And it's not just a plan that you put on the shelf and, oh, we have a storm, then we blow it off, blow all the dust off and work it. Now, actually here in the state of Florida, that plan has to be approved by not only the state and also the local chairperson of the Board of County Commissioners every 5 years. So it's constantly updated. It's a living, breathing document that guides us on how we're going to prepare for and respond and recover from man-made and natural disasters. Also, there's Department COOP. The COOP stands for Continuity of Operations Planning. This is a requirement under the National Incident Management System because we're government, and government, we don't get to say, well, we got to take time off because our building burned down. That's not acceptable. So the COOP plan basically is, and I'll cover this here a little bit more in depth as we go through the presentation, but the COOP plan is dictated that every government has to have a COOP plan on how we're going to continue plans after a disaster. The other thing that's kind of a requirement, especially here in Sarasota County, is every single department within a county or a government has to have a preparedness plan. And the preparedness plan basically covers, time frames on if there is a pending disaster or there is a disaster in the community. What is that plan? What is that department's responsibility? Who's in charge? Who's going to take care of what to go through the process of getting the county or the government back to normalcy of some reports. Next one you see on the screen also is called a flash report. Flash report is something that we started a couple years ago. We send this out to all of our county employees. Flash report contains anything from weather situations to currently with COVID. We send out, what the daily or the weekly data is on COVID reporting. Flash reports are basically intelligence for employees to know so they can take necessary actions not only at the workplace but more importantly at home to make sure that their families or their loved ones are safe. We also use Smartsheet for tracking of data. I'm not too well versed on Smartsheet. We have folks in our office that are way more smarter than I am that create these Smartsheets, and they pull in data from all other agencies through different types of links, and that helps us look at trends that are going on. And then Everbridge. Everbridge is a software system that we use for messaging employees. Some of you may have heard the term Code Red or Reverse 911. But the Everbridge is something that the state of Florida actually put into place a year ago. They're paying for this messaging system, and it's by phone for all the counties to use to message employees, but also message areas where maybe we've had a drinking water system fail, and so it's a boil water notice. Well, our Department of Health or Environmental Health would use this Everbridge to call to those affected homeowners in that specific area to give them an alert or a warning. All right, let's talk a little bit about COOP. Like I said, federal government requires all governmental agencies and entities to have COOP plans, and COOP plans are basically a continuity of operations to make sure that after a disaster that we can get back to normal operations as quickly as possible because, again, we're government. It's what the taxpayers expect of us, and this is why we have these plans. The objectives basically of the COOP, again, to assure survivability of government. We need to make sure that we can be up and running. Continue essential operations. Again, government, we have law, we have fire, we have utilities, we have Department of Health, we have Parks and Recreation, we have libraries, we have roadways, public works, public utilities. So again, COOP plans are designed for all of the government entities to get back up and running and to be at least full service as quickly as possible. Also to protect critical equipment, records, and other assets, but also to minimize damage and losses. Part of the COOP plan also is for governments to identify that where if you have a facility or you keep your vehicles in a certain location, well, part of the Coup Plan is if you know you're going to get a flood or a rainstorm or a hurricane, where to move those items so that it minimizes the damage to those vehicles or the facility. Coup has a lot of different chapters in it, if you will, for lack of a better term. Basically, is who's in charge and who starts the whole Coup programming possible. Where are the alternate site locations? Like here, where I'm speaking at now, this is called the Emergency Operations Center. It was built in 2015. It's rated to Category 5. However, we can't rest on this is going to survive any type of hurricane or disaster or whatever. So we actually have 2 different backup emergency operations centers within Sarasota County that would be actually able to be up and running within a matter of hours if this building was ruled that it couldn't be used anymore. And that's the same with all governmental entities. They have to have Coup sites. If your city hall burned tonight, where's it going to be? Where are you going to start work tomorrow? So things like that. What is important? Task list for each role or the team. Who is going to be doing these items and what their role is. When? How long is it going to take to get those items up and running? And then what resources are needed? Again, using the analogy of this building, our Sarasota County Emergency Operations Center, if it was ruled and kept, we couldn't work out of this building. What is the time frame to set up at our other 2 primary locations? I will tell you our 911 system for our secondary location could be up and running within a matter of 20 minutes. So, because again, we're government, we have to be at the ready. And then who's in charge? Who's going to make decisions and who's going to take care of those items? Now, again, talking emergency management, we always think about, it's about hurricanes and things like that. However, we've had another item that came to rose to the level last year was cybersecurity. There's many governmental agencies, especially here in the state of Florida, that have been affected by cybersecurity. And in fact, there was a county to the south of us that actually had some of their data was corrupted. So part of the Coup Plan also is how are you protecting your data? All right, going to talk a little bit about, for still on the Coup subject, is that 3 scenarios for you. Loss of a facility with little or no warning. How does that all work? And that type of incident, again, it happens overnight. It could happen today. Where are we going to work? Where are our employees going to go? Who's in charge? Who's going to make these decisions? An impending threat or limited time to prepare. Hey, on the screen there, you see that little, that one graph that has all the different colors within it. That is actually a software system that pretty much every county in the not only state of Florida but others use. It's called Hurravac. It's a planning tool for us that kind of gives us different scenarios and time frames of when tropical force storm winds are going to make arrival here in our community. And those help us make plans on when to open up shelters, transporting people with special needs, closing down government, alerting the public, so on and so forth. And then disaster impact response and recovery. You can see all the debris there. Like I said it several moments ago, debris is usually the most costly item to governments post-disaster. So we have to have some type of plan in place and contractors at the ready to help us out. And while I'm speaking about debris during Hurricane Irma, and we talk about these contracts, and I'm sure all of you have contracts too post-disaster, just make sure that your contractor, they say they're going to be there and help you. Well, let's just make sure that you have certain stipulations within their contract to help you with that. Because again, you probably all heard during Hurricane Irma, several contractors wouldn't come, particularly here in Sarasota. We have 3 different debris contractors that are hired to help us out under contract. One said they weren't going to come, and so we said, yes, you are, because we have a contract with you. So it took some finagling. But Hurricane Irma affected 54 counties out of 67 counties, and a lot of these debris contractors had contracts with these 54 other counties. So they got spread too thin, and this is why we had the issue of debris cleanup post Irma. Loss of facility. This is for all of you. You should have a Coup Plan. If you haven't, check with your local emergency operation or your local emergency management to help you with this. But again, your facility burns down, like you can see in the picture here, or is somehow destroyed in a tornado or whatever. You know, what are your employees to do? Where do they report to? Used to be everybody would say, well, we're just going to come to the Emergency Operations Center. Well, no, we don't have the room for that. So, again, we need to make sure that part of the Coup planning is identifying locations for employees to work out of, so that that county government or that government entity could work out of that. And that alternate site, does it have the power? Does it have the internet capabilities? Does it have all the software needed to that how you did your job yesterday? Now that you're at a new facility, it shouldn't have it there. And then last and most importantly is, have you tested or practiced your plan? Do all your employees know what their roles are? We preach here in county government because all of our employees, they have to, it is mandatory. All county employees have to take the ICS 100 and 700 in classroom. It's an online class, but we have them come to here at the EOC, and it's mandatory. Every new employee has to come and take the class in person, and we talk about these things. And one of the items that we emphasize, part of the Coup planning, is make sure the employees have a go kit. If they can't work out of their building tomorrow or to whatever, what essential equipment do they need to take from their office to take to a potentially new location? We could have a fire that happens in the building that you won't be able to work out of, or like this picture, a severe storm came through and knocked out some windows. Could have some flooding. Prolonged electrical outages. A couple years back, there was an electrical outage down in the Miami area that might have affected even the, I think it's called Turkey Point nuclear power plant. So what is the Coup plan if these things go out, and how is that all going to work? Pending threat, limited time to prepare. One of the items in Basic Incident Command System classes, ICS, is called an event or an incident. An event is something that we can plan for. An incident is something that happens right away, and we didn't really have planning for it. So, question to ask yourself, hurricane. Is a hurricane an event, or is it an incident? So, to answer that, basically a hurricane is both. It's an event because we can plan on it. With technology today, we know pretty much we can watch these storms as they form off the coast of Africa and move their way westward across the Atlantic. And then we pretty much, with this HurrAvac system, again, I have it on the slide, pretty much gives us an indication time-wise of when we can start seeing the impacts of the storm. So now when the storm makes landfall, then it becomes an incident. And that incident, again, requires a response to save life and property. So again, limited threat, impending threat, limited time to prepare. What steps does your department take? Again, this is part of your Coup plan. And those of you on the line listening, again, when we hang up today, you may want to just check with your supervisors or your local emergency management. What is our plan if we can't work out of our building today? Or what is our Coup plan? And also, do employees know what to do? Here in Sarasota County, we're a little bit unique. Every single one of our employees that are under the Board of County Commissioners, non-sheriff, non-elected offices, every county employee has a role. It's called a employee E-role, or employee emergency role. And basically, every employee has to sign up for whatever the role is going to be, because again, somebody that's working maybe at a library, they can't work at a library, so they're going to have another role, and maybe that role is working at one of our Gen Pop shelters. So everybody has to sign up for an E-role. One of the other things that we're working on is if you're going to have to evacuate, where you're going to go, but also what's the plan for your family. Again, we're government. This is really hard, but this is what we do, and some of us have to leave our families behind. So that being said, what is the plan for your family? During Hurricane Irma, obviously with my role here at the Emergency Operations Center, I had to stay. My wife was at home. Kind of tough for me to leave her at home. I asked her to go stay with our children. I have a daughter that lives up in Brandon, or my son that lives up in Inverness. She didn't want to go. She wanted to stay here with me, and kind of heart-wrenching, but it's what we do as government employees. So make sure you have a plan for your family, that they're safe and be well-being. Are your employees prepared? Again, any agency, the biggest asset is our employees. So we have to know how our employees are prepared. What are they doing with their families? Do they know their evacuation zone? Do they have a plan on what they're going to do? One of the items after Hurricane Irma, let me back up a minute, but in the emergency management world, whenever there's an incident, we have to, when the incident is finally over, we have to prepare what's called an after-action report. And after Hurricane Irma, Sarasota County government's after-action report had 93 items that we could do better on, because the after-action report shows us what we did good, but what we could do differently. So we had 93 items, and some of those items were our employees on, notifying them and keeping them informed, and where are they going to go, and what about their children, because, some folks have to come back to work and they have kids. So basically we've looked at that, and we've revamped some of our plans to help our employees out, so they can come to work and not, obviously you're still going to think about your families, but at least they can come to work knowing that their families are taken care of. Disaster impact, response, and recovery. Again, all departments and many employees are impacted. So if your building is damaged, you know where your employees expect to work. Again, that's basically part of the Coup Plan. I think this is a duplicate slide. Now, getting from the county level down to the individual departments, departments should have, under the NIMS, the Coup Plan, identifies proactive actions, staffing, and timelines to complete actions based upon their critical operations and critical infrastructure, as well as additional assignments. What this is basically is departments are expected to have some type of timeline, because like I told you earlier, pretty much every county emergency management office has this Hurravac software system, and it can kind of give timelines on when to expect tropical force storm winds to hurricane winds, how big those, or how fast those winds are going to be. So here in county government, we work backwards. If we know that we're going to have a storm, say next Monday, we have already started our plans. We actually probably started on Wednesday of this week. So it's a timeline that goes back 120 hours, then works its way down to 0 hour, which is landfall, and then post-storm up to 40 hours. One of the items of Hurricane Irma, the 93 changes that were recommended for us, again, getting back to employees, was closing government. We've made the conscious decision to close government when we've got about 24, 48 hours pre-landfall. This allows employees to go home, take care of their families, prepare their homes, and get ready, and then come back to work. And then opening county back up. With Irma, as soon as the winds died down, we were directed to open up county government. Well, a lot of our areas weren't ready, especially the public utilities with the pumps that they have and everything. So one of the recommendations that we're following and have instituted, we'll open up government when the department directors feel that their individual departments are ready to open back up. Again, the DDPP, just like I mentioned, it's 120 hours pre-landfall, and basically benchmarks for departments to make sure that they're getting ready. And this whole DDPP is still part of the continuity of operations planning. It's making sure that we, county government, can be back up and running as quickly as possible. And this is kind of what it looks like. It's a smart sheet, and it allows us in the Incident Command Center to kind of look at departments and where they're at, and if they have any issues. Because if it's in red, that means they have an issue, and we can help them get to where they need to be to make sure that their employees and all of their roles and responsibilities, their facilities, their vehicles, everything are protected. So post landfall, we can get back at it. All right, this is a flash report. This is something that we've done here in county government, and this is basically a report of any type of storm, weather incident that's going to affect our community. We send this out to all of our county employees. This goes out to other entities within Sarasota County. It goes out to some of our citizens that have the community emergency response teams, and it's just basically an overview of what's going on and what county government is doing to prepare for, respond to, and mitigate the effects of the disaster. And this is basically what it looks like. And this was from Tropical Storm Eta. So you can see the different actions that county government has to take care of. All right. Again, emergency management. Our emergency management chief, Sarasota County, is Ed McCrane, former military, so he uses this Semper Gumby. So, and with that, does anybody have any questions about emergency preparedness that I can answer for you?
Good afternoon, everyone. Has everyone been able to take like a little break to stand up? I mean, we are a couple minutes early and we have way too much to do. I just want to make sure everyone is reasonably comfortable. We've, I think, had a lot of good presentations. My name is Dr. Mel Kramer. I've been an environmental and infectious disease epidemiologist. I started out as they call them sanitary inspector first grades. I've been a health officer, and I've run a consulting firm for the past 40 years, and I employ about 7 or 8 REHSs. So I'd like to go over this fairly quickly. We don't have a lot of time. Institutional sanitation, I could spend an entire day on. When you look at what is institutional, virtually everything becomes an institution where you have some type of specialty services, schools, universities, hospitals, jails, nursing homes, group care facilities, camps. All of these may have separate entities in law and practice, but a lot of them have a lot of commonality. Now, I recognize it only makes up 5% of the questions, and I also understand there is definitely some epi and infection control crossover. So I want to go through these slides. Here's a list of them that you can see. I think that right now we are much more interested in COVID with understanding what's gone on in nursing homes, now schools and daycare centers, nosocomial infections from hospitals. Prisons have had an extraordinary burden of COVID, as well as transmission of other communicable diseases, ranging from norovirus to tuberculosis. The duty of the state is to ensure that institutional facilities meet minimum standards for environmental health and safety. That's a very nice statement. However, different agencies have different responsibilities in different facilities. Nursing homes may have some state responsibilities, but if they take Medicare, they have some federal responsibilities as well. So, a hospital has JCO, the Joint Accreditation of Healthcare Organizations, responsibility as well as responsibility to Medicare, Medicaid, which is CMS, the Center for Medicare Services, as well as the state and local responsibilities that occur from time to time. This is the entire practice, in a way, of environmental health. You have to have good water. You have to have good wastewater. You have to have proper disease control. Your indoor air quality. We kill patients in hospitals. When we do construction, we don't think of Aspergillus fumigatus that's in the recesses of the ceilings that become a indoor air quality, which I guess is on our next section, but that's a very important thing from an indoor air quality as well as ventilation. Obviously, pest control, plumbing issues, food service, biohazards, laundry operations. There was an outbreak that was attributable to the laundry in a hospital that was not hot enough, as well as obviously aseptic techniques. So this area fills almost all of the boxes that you have, and we could even add in a hospital radiation safety. We can certainly add surging in emergency management. So everything that we've discussed this morning comes to roost in some of these institutional settings. Depending on the size of a facility, some may have in-house potable water supplies. They may have their own solid waste initiatives. They best have biosafety. The OSHA is pretty strict on bloodborne pathogen control. Everything has to really go well, and the interest of all of these segments clearly goes to the environmental health specialist. The registered environmental health specialist is really the glue to all of the other professionals, whether they be doctors, whether they be nurses, whether they be food service management, occupational health specialists. So your role is extraordinarily important, and I dare say very, very much understated in the minds and hearts of people either in the community or people that we regulate. We basically have a lot of commonality with issues in the general community as well as in the institutional environment. We have opportunities for disease transmission person to person as well as by fomites. We have invasive procedures, and this is much more of a healthcare statement. We have immunocompromised individuals, and we have to make sure that all of these procedures are carried out in a sterile environment, as well as that we have proper waste flow, whether it be infectious biohazard, sharps, needles. And what's very interesting in this slide is number 2, highly stressed and overworked employees. And with COVID, that's exactly what we're seeing. And when we have that, we both have physical and mental health issues, but we also have quality issues with other professionals. Institutional populations We have very young, very old. We have people who are physically, mentally, and emotionally challenged. And a lot of these people are on the spectrum of having reduced immune systems. Therefore, whether it's by their underlying disease condition, age, etc., makes them real good candidates for disease transmission due to their lack of resistance. And remember one thing, immunocompromised or immunoaltered also can include people, a healthy kid who uses a puffer for asthma. That steroid does compromise one's immune system, as does even something as normal and healthy as being pregnant. We probably can skip over this one. Nosocomial obviously is a Greek word which basically means hospital-acquired infections. We didn't pay a whole heck of a lot of attention to nosocomial infections for a very, very long time. And now it's actually a very high priority because if you give someone a nosocomial infection, especially somebody over 65 on Medicare, you own them and you pay for them. So they've been able to reduce 50% by just really enforcing hand washing. We're very, very concerned about bloodstream infections, surgical wound infections. Urinary tract infections are pretty common, especially with catheterized, indwelling catheterized patients. To stratify them by medicine, gynecology, and obstetrics is one way of looking at it. But just like we look at universal precautions to say that every patient is capable of having a bloodborne, whether it's HIV, HCV, Epstein-Barr, whatever, we have to also look that every patient has the opportunity of getting a nosocomial infection. And some of these bugs are very, very resistant to antibiotics. And that's very, very important. And we're getting very concerned about some of the Enterobacteriaceae, which are becoming antibiotic resistant. You've all heard of MRSA, which is an aureus, a Staph aureus, Klebsiella, a lesser extent. I just spoke today with someone about Clostridium difficile. This not only is a nosocomial infection associated with antibiotic use, but it also can be an environmental contaminant because the Clostridia, as I'm sure you all know, are spore-forming bacilli, and as such, they can withstand a certain amount of cleaning and sanitization, not sterilization. So these are really, really important things to understand for nosocomial infections. Hand washing is the number one. And whether you're looking at the word cross-contamination in a food establishment or in a healthcare facility, whether it be a nursing home or acute care hospital, all of that gets back into the mindset that we have to make sure hands are clean, gloves are changed, etc. We've done some things during COVID that we would never do. Reusing masks for 4 and 5 days. People would be fired for that in pre-COVID, but that was survival. We have had food-borne outbreaks in institutions, whether they be camps or jails, but also in nursing homes and acute care hospitals. We'd like to prevent overcrowding. Again, depending on the institution, it may be in the eyes of the beholder. Many jails and prisons have federal orders that they have to thin out their population because it's really unsafe. And that's when we get a lot of the diseases that we shouldn't have, such as tuberculosis. A lot of these people have latent tuberculosis to begin with. We look at antibiotic stewardship, which is clearly not something that is in our purview, trying to get docs and other healthcare providers not to use antibiotics unless it's absolutely necessary, and use antibiotics very sparingly. And in an institutional setting, the pharmacy should suspend the antibiotic unless they have an absolute a culture with a sensitivity to that specific antibiotic. And infection control committees, it would be nice to have a full-time environmental health officer. Usually there's a nurse who's in charge of infection control. And just like I like to think that, a lot of people in the dietary department are registered dietitians, that does not substitute out for an REHS. And I have in my career stated to them that you would not like me to prepare the dietetic requirements for your patients. So please don't tell me that you understand environmental health and safety in terms of your food service facility, both on the floors and in your main kitchen and on your lines like we do. I think that everyone in the world understands PPPs now, PPEs now. PPPs are the payroll protection, obviously, but the PPE is the protection of your body, whether it's a mask, whether it's a glove, whether it's a hat, whether it's booties, whether it's an apron. It depends on the environment that's meant so we don't acquire infections and we don't pass off infections. And there are very, very strict surveillance and control guidelines from the Joint Accreditation of healthcare organizations. And obviously the CDC does give guidance as well. We stratify levels of care, acute care being a hospital, subacute at times can be at a rehab center versus a long-term care. And then sometimes when we have people who can't take care of themselves, there's an intermediate step here, which is highly unregulated in most areas. Before a nursing home would be what they call assisted living, where people do have more independence. Meals, they may share them together to go down at a certain time, or have the ability, depending on the facility, to have it in their room. Obviously, the bottom line of all of these things is cost. People who go to a rehab after a 3-day hospitalization from a hospital or over 65 get a certain number of days free and a certain number of days at 80%. Nursing home care is basically not really provided by Medicare. Medicaid it does in some instances, and assisted living usually is not covered at all. So there's a tremendous financial burden on the individual and their families. When we talk about infection control, I'm sure you really know that the weakest link of a chain is where you're going to have the problem. There's always going to be sources. There's always going to be people who are susceptible, and we always have modes of transmission. what we have to do is we have to really take a holistic approach. And I think professionally, we have to take a holistic approach to environmental health. We are the guardians of the community in practically and communicate protection. I hate utilizing and quantifying in dollars the what a person's life is worth in terms of productivity or misery or pain and suffering. But unfortunately, when these things fail, there are plenty of attorneys that are very skilled at getting compensation for these victims, and some of them absolutely deserve it. So I'd rather have these companies, especially nursing homes, put their money into primary prevention. Hospitals basically do. They have morbidity and mortality committees, or doom and gloom, depends on how you like to talk about it. They have a lot of surveillance activity, both laboratory and patient, and they know who's in the hospital and what bugs are being transmitted, or they should. We have some new bad actors. I did one in a hospital here in South Florida, where a mycobacterium, which most people think of either tuberculosis or leprosy, but these are fast-growing ones, can be a nosocomial infection with what we call deep wound infections with orthopedic surgery. And these can be very, very challenging. Now, one thing that you really need to understand is the difference between clean, which I know you do, sanitization, which I hope you do, and sterilization. Sterilization is the absence of microorganisms, including spores. That's a very important concept, and it really should be on the test, where sanitization is a gross reduction and hopefully the elimination of most all pathogens. And clean, well, it looks clean, but microbially, we're not sure. There's no question that if you take a surface and wash it, the fact of abrasion with soap or whatever does reduce the microbial load. The bioload is a number of microorganisms on a surface, an instrument, or whatever, and it too can be measured. Epidemiological investigation. I think you're going to have a session on epi. As an epidemiologist, nobody knew what the heck we ever did. As a matter of fact, I got a new T-shirt saying, "I'm an epidemiologist." No, I'm not a skin doctor. The textbook definition of epidemiology is the study of the distribution and determinants of disease, which is very interesting. What populations, when you look at the distribution, what populations are we seeing this disease in? What population has a higher incidence of this disease? And the determinants is usually a lot easier. Is it a virus? Is it a bacterium? Is it a chemical? So that's basically what the study of epidemiology is all about. And again, I think you're going to have a very good lecture on epidemiology from a very good epidemiologist from the state. And I think they are truly unsung heroes in this COVID crisis. And I will just make one comment. If it wasn't for the chronic disease epidemiologists, we wouldn't have vaccines and therapeutics, because they're the ones that actually crunch the numbers and make sure that all these studies are conducted statistically correct and reported out. We do much more of the infectious disease epidemiology, whether it's an outbreak of salmonella at the neighborhood restaurant, or when you're getting involved with COVID. And so there's a lot of epidemiology that I think you should know, and you probably do know. BSL, or biosafety levels, are environments, laboratories. I don't think it's that important for you to know. I mean, I've been to a biosafety hazard level 3, where you get into a moon suit with an air pack. I actually went into a couple of these with BSE, bovine spongiform encephalopathy, or mad cow disease. Most laboratories go on a level 2 because if they have any pathogens, they really need to. And obviously, a bio level 4 are Ebola and exotic diseases that pose a tremendous risk to not only the public, but also to the scientists and researchers. So when we look at our role in an epi investigation, depending on what county or what position you have to understand both the principles of epidemiology as well as understanding what disease you are looking at. Obviously, if you're looking at salmonella, thinking about their HVAC system is really not going to be very, very helpful. So you have to understand basically the 3 things that we call the epidemiological triangle, which is we have a host, we have a reservoir, and we have a vector. So now, what's our reservoir of the disease? How does it get to the host via what vector? So it's the who, what, where, when, and under what circumstance questions that most epidemiologists are charged with understanding. And I pride myself in being a shoe-leather epidemiologist. Doing outbreaks takes me, I think I've been to I don't know how many countries, and it's interesting because it's all the same, just different cultures sometimes get a little different, but epidemiology is the same. And the most important thing that we can do is be inclusive and try to understand what is going on in order to solve our problem, because the job of general epidemiology in a health department is, number 1, identify it, number 2, stop it, and number 3 is how do we learn something to prevent it from happening again. And I think one of the worst problems we have in public health agencies today is we lack communication. And when I say communication, coming to a FEHA meeting is communication. You're learning, you're teaching, you're able to give people some of your insight that they might be able to apply when the same situation happens in their jurisdiction. And unfortunately, that's a political and therefore a financial issue. Fire safety is clearly something that's important, but usually the fire marshals take that job away, and most of us are not really that in tuned. I think we do more work on burn safety, maybe in a food establishment or in a school. If we do schools and we look in their chemistry laboratory, that they may not have proper protection, but basically fire safety in institutions are left best to the fire marshal, et cetera. people don't understand in hospitals, there are all sorts of problems providing anesthesia. People have actually caught on fire under anesthesia, and no smoke detector is going to really help that. So there's some really interesting pieces of fire safety. Hospital wastes, I mean, you can only imagine what comes out of hospital waste, and basically everything comes out. I mean, and most things should be treated as infectious, although some of them are not. Clearly anything with blood and sharps and things like that are. Clearly radioactive waste is not infectious, but that has to be taken care of in a special way. Food service waste, again, what do they do with their patients that are in isolation? They should be served on disposables, and then those should be red bagged afterwards. So there's a lot to be done, and in that, and if you are a hospital environmental health specialist, you understand this. The hospital laundry is something which I like to spend a little time on because it has a lot of interesting things. Most hospitals have clean linen areas and soiled linen areas. We don't like soiled linen to be just traversed through the entire hospital, and to get to the laundry facilities, they must have a thermal depth of 160 to 167 degrees for 25 minutes. I think lightly soiled linens for non-isolation areas at 140 degrees. I guess it's adequate enough. I don't see why we just don't have everything at regular temperatures, because not everything's cultured, and you think it's lightly soiled and not isolation, and 15 minutes later the patient's moved in to an isolation room. So it's really important that the water temperature is very, very important, and not overstuffing the machines. So you're really going to get confluence of both the water with the utilization of bleach, as well as to be able to dry, which again is a heat. Sometimes we look at removing excess water from textiles with extractors. I don't want to get into floors, but some hospitals, some institutions like to have carpeting versus tile, and then you get into the whole thing about the textile cleaning and sanitization. Kidney dialysis machines. Again, they have very, very strict protocols. These are absolute specialists, from the nephrologist to infection control nurses, and this is something I can tell you. Many years ago, when I was director of environmental health in Baltimore City, we had a 44-inch water main break, and as some of you may understand the political ramifications of this, the mayor goes on television and says there's no health hazard, nothing is done, which made my job so much harder. I closed every restaurant within the affected area, and I made a beeline to the kidney dialysis center, and we shut that down. Why? Because what we were afraid of is that there could be some grit getting into the system that would be purified, but possibly go through some of the filters. So you always have to look at the holistic ramifications, thinking outside the box of what's normal. Of course, food service without water we can't have. But what about other areas in the community that are very, very sensitive? Schools, colleges, universities, you discussed swimming pools. You know, the hospital, I think they have little dispensaries now. When I went to school, they had, inpatient, when you were too sick to be in the dormitory. Now they either throw you back to the dormitory or, I guess, to your parents' house, or if you're really bad off, to the hospital. On-site housing, off-site housing, fraternity, sorority houses, all of these things are all part of things that are done in colleges and universities. Insect and rodent infestations are not that uncommon, and as we know, whether it's a fire safety, an electrical safety hazard, people will cook where they shouldn't. Obviously, there are safe ways of cooking in a dorm room and unsafe. Hopefully, the school has good surveillance of that activity from resident advisors, etc. Correctional institutions. I don't know how many of you have been to jails or prisons. I have. I actually closed the food service facility in one that was so disgusting. And after being told I couldn't, what would the prisoners eat? And I told them very calmly, for dinner, you can cater McDonald's into them, and for breakfast, they can have a little box of cereal with some milk, and hopefully you'll clean up and get rid of your extreme insect and rodent problem, and we'll be able to reopen you. Obviously, that wasn't the most popular decision, but it was the right one. And I think one of the things that we need to be as holistic environmental health officers with the registry that we have is we always have to look out for the betterment of the people, whether we want to socialize with these people or not. What they've done, it doesn't matter. They are someone who deserves to be treated not with rodent-defiled food, but clean food. That's at least my belief. As you know, they have all sorts of healthcare facilities that go from abysmal and neglectful to putting them out into the community, and they get some very, very good health care. And I can tell you, federal facilities have gotten much better. I have not been in any local ones recently. I can tell you I did testify on behalf of the federal courts whether or not some prisoners or detainees should be let out of jail under certain circumstances to home for their fear of COVID. And some of it was real and some of it was a good try. We don't get involved in prison unrest. Food-borne illness is clearly something that they have. Norovirus goes rampant. Look, these people are not eating food like you'd serve at the Ritz. This is not it. I mean, it's sustenance, and one can argue whether or not it's appealing or not, but that again is not our job. Vermin infestations does fall under our area of expertise, and how they work and how they recreate again is marginally something that we would get into, but it would certainly, especially in this day and age, to make sure that weights and things like that are cleaned and sanitized with appropriate COVID protections. We don't know whether or not COVID will be on the exam, I was told the other day. Daycare centers, they're just sort of children basically will get an upper respiratory or a GI bug every 4 to 6 weeks when they start daycare. Whether you start them, at 3 and 4 months, or whether you wait till they go to kindergarten at age 4, 5, or 6. So it's also good for their immune system, preventing children from sharing things, whether it's biting a toy or sharing food, or is mission impossible. We try to make sure that the diapering is segregated, and extreme hand washing, that people really wash their hands if they're the ones that are going to be feeding and preparing food for them in small clusters nowadays. They're bubbling them. So if someone becomes COVID positive, they have a defined pod. So it's good infection control. As I said, enteric and respiratory diseases are very common, and most of the time, daycare centers, don't have horrible outcomes. The problem is that when kids are sick, they're sent to daycare because mom and dad usually have to work, or mom and mom, or dad and dad, however the mix is. So that's what goes on not only in daycare centers, but also at schools. You've heard a bit about cryptosporidium or cryptosporidiosis. That's something that is somewhat common. Giardia, Salmonella, Shigella, I would put at a higher rate, as well as norovirus. Kids should have rotaviral immunity through immunization, but they also come with all sorts of Coxsackie viruses, coronaviruses, not COVID-19. As a matter of fact, one theory is that one reason that young children don't seem to be that affected by COVID-19 is that they have had such recent bombardment with other coronaviruses that there might be some type of immunity or cross immunity, but that's very, very speculative. Again, personal hygiene, frequent hand washing, teaching the kids to hand wash, good food sanitation. Ill children should not be in a daycare center. If they become ill, they need to be segregated with a teacher, and the responsible adult needs to pick them up, and they should be free of fever for 24 hours, as well as they should not have vomiting or diarrhea for 24 hours. That's usually the standard that most daycare centers and pediatricians will go through. ASHRAE is the American Society of Heating, Refrigeration, and Air Conditioning Engineers, and they are the professional association of these people. We like to look at 73 to 77 degrees as a recommended. Here in Florida, sometimes 77 would be pretty hot. Low humidity is nice. And again, different environments would have different temperatures. Frail adults would probably need it to be a little bit warmer. Kids running around would probably need it a little bit cooler. When we look at recommendations for indoor relative humidity, you really want to make sure, especially down here, that when you have indoor relative humidity of 60% or higher, you'll cause condensation, and then you're going to have fungal diseases or fungus in the classrooms or other areas, which can lead to both allergic and invasive disease. So I guess that ends our institutional sanitation. do we want to take any questions? I went through more than a day's worth of a lecture in a very, very short period of time. Hearing none. Michael, are we on time?
Take a couple minutes with the air pollution.
Okay. I'm trying to get the slideshow to start. Why is this not showing as a slideshow? Okay, from the beginning. Air quality and noise. Okay, well, we're going to do this pretty quick. It's again 2% or 5 questions on indoor air quality. Probably noise is not going to be mentioned. We'll see what we can do and get some occupational health as well in here. You all know that health impacts, air pollution impacts health. We do have some standards, we have regulations. Sometimes we sample, and sometimes we don't. We take in more than we think we do, and we actually take in about 35 pounds of air a day, and we have a lot of people with asthma. Smoking increases both lung cancer, chronic obstructive pulmonary disease, emphysema, chronic bronchitis. By the way, chronic obstructive pulmonary disease is also sometimes called COPD, as well as other things that go on, whether you're having lead levels, mercury, or carbon monoxide. So that's something that will we're not going to have a lot of time. Now, we have lots of economic pieces, which again is a 30,000 foot level. I did a little research on the RES question. It was a very interesting question I saw. When we get into air pollution, there's some strategies that we use to prevent air pollutants to get out, and one's called a scrubber. So the question was, what waste byproduct is generated from sulfur oxide scrubbers? And the answer is sulfuric acid, because the sulfuric acid reacts with the water in the scrubber to form acid. It's also an important reaction in the atmosphere where sulfur oxides react with atmospheric moisture and forms acid rain. So even when you have a good air pollution control device, you still can have negative outcomes. I think our biggest issue is down here in bioaerosols. We have a lot of issues with mold, more than almost anything else. I mean, we don't get involved with forest fires and ocean sprays. I mean, obviously, when we have certain levels of warning, certain people have got to stay indoors in air-conditioned environments. What we are looking at is particle size at times, what can really get into the deep lung tissue. And that's really what we're looking at. And everyone now knows about N95 masks. So when you look at dust and pollen, you're looking at basically boulders. Look at the difference between beach sand. So the things that really get us into trouble are these very, very small particles that are really at the 0.1 microns or less. We have hydrocarbon issues. We have oxides of nitrogen, which also are problems. We have ozone issues. We have volatile organic compounds, formaldehydes, peroxides. There's all sorts of pollutants that get out there. Our principal source of hydrocarbons as a fuel gives us obviously a principal source of pollution. You all can access this. I mean, it's too dense for me to go over, especially since I don't have a lot of time. We have the Clean Air Act. Over the past few years, we've had some relaxation. Who knows what the next 4 years will go with. There's regulation of 188 chemicals. I have to tell you that some of these carcinogenic chemicals, what chemical companies have done, for those of you who have taken chemistry, enough of it, they just change the isomer, and it's not on the list. So we have a ton of regulations, and we have a ton of understanding of what causes health and what causes health issues and what does not. And we have to lower our carbon footprint in any way we can, and that's become a real buzzword, and some people get very upset with it. But I think there may be some very good strategies, and I'm pretty sure there's some pretty bad strategies. We know that here in South Florida, I know most of you are not in South Florida, but in South Florida, and even throughout the state, we sometimes get sand from the Sahara that just comes in off the wind. That's pretty far out to say that we're getting Sahara sand thousands of miles away. We get radiation from the sun. So, I mean, the one good thing is when it actually rains, we get a lot of the pollutants that actually is a natural cleansing process. So that's really good. There used to be a horrible statement: dilution is the solution to pollution. So in other words, if I dilute it enough, I can do whatever I want to do. Wrong. And if I make my smokestack higher, it will just dilute more. Well, that may well be true, but that doesn't mean it's healthful. We like to control it at the source. There are all sorts of emission control devices, like the aforementioned scrubber that I mentioned to you, particulate collectors and separators, gaseous collectors, and treatment devices. And a lot of major plants operate fairly clean by doing this. There are all sorts of different things. Electrostatic precipitators are very popular in some. Scrubbers, as I mentioned, is another one. Baghouse filters. I will tell you, I've been to some dirty industries. I've seen their bag houses and their cloth screens, and it's pretty impressive, and it's pretty messy, but it does prevent things from going. Basically, these are diapers. That's all they do. They catch them. They still have to be disposed of somewhere. Noise control obviously can cause hearing loss, whether you look at the actual what you hear versus the vibration is important. Definition: noise is an unwanted sound. I think that what we're looking for is, matter of fact, if anyone has the new iWatch, there's actually a decibel reader. That's how we measure the amount of sound in terms of decibels, and we do have some definitions for noise pollution. Many places actually have ordinances for noise pollution, and again, what's enjoyable to you may be very obnoxious to the next person, whether it's the motorcycle going down the street or somebody, blasting out heavy metal. If you like heavy metal, it's wonderful. If not, it's just an obnoxious noise. So a noise level is weighted sound pressure level in decibels, and that's probably a good. You'll feel pain at 120 decibels. There's no question about that. And they have different things, what a jet engine is versus whatever you should. We have occupational health regulations for decibels, and that's why people have to have earplugs or ear muffs that will make sure that they are not going to harm their ears. Usually 45 decibels is good for indoors, 55 for outdoors, but you can see that there are lots of things that go way higher than that. And also, like everything else, there is a time and an exposure level in terms of harm. So you might be able to take 8 hours at 85 decibels, but at 100 decibels, you only have 15 minutes to have your daily allowable kind of dose of that. NIOSH is part of CDC, which is the National Institute of Occupational Safety and Health. I'm sure all of your health departments have calibrated instrumentation, and I can tell you that from a community public health perspective, nuisance complaints, whether it's barking dogs or noise pollution or whatever, are, sort of the bane of existence that goes on. I'm sorry I had to rush through all of this, but there's a lot of material, few questions. I wish you all the best of luck in your exam.
I'm glad that the previous person was able to cover some of the EPI information as well, because really I'm doing more food protection. At the end, I have just some EPI terms, and we'll be interjecting as I go through. But here to just start real quick, foodborne disease is really any illness that's associated with a causative agent that has ingestion of food, being foodborne. We often call this foodborne illness. You'll see sometimes FBI used as the initials. It's not the federal agency. If not, just sometimes people write foodborne illness as FBI. Food poisoning is any substance that secretes a toxin, and it is the toxin that makes you ill, not the bacteria itself. And we'll go a little deeper into this once we're talking about bacteria. Food intoxication, again, is that byproduct of the bacteria, the toxin. It's often a pretty rapid onset and that causes the foodborne illness. There's also chemical poisoning, which is any chemical present in the food. This can be intentional or accidental, but chemical poisoning is another form of food poisoning. Foodborne infection is when the organism itself, again, not the toxin, but the actual bacteria, virus, or parasite causes the illness. And then when we look at what is an outbreak, it is when a foodborne illness that is including 2 or more people that had common food, symptoms, and place in common Here we have with laboratory analysis, but as we will see later on, sometimes that doesn't happen. So we definitely talk about same pathogen or same symptoms, similar food groups, and a timeline that is uniting them as an outbreak. We do have special cases that are single outbreaks, and this often is chemical exposure, certain marine toxins such as ciguatera, scombroid, fish poisoning, mushroom poisoning, etc. So there are some exceptions where outbreaks would be single cases. Drinking water, we had a whole section on it that we want to make sure when we're talking about food protection that we're using potable water or drinking water. And so we want to be sure we're meeting the specifications of 40 CFR 141 and that a lot of Environmental Protection Agency regulates the clean water. And I wasn't sure where to stick this in, so I just food criteria. Eggs can be defined as a liquid, frozen, or a dry product. This should be pasteurized. Otherwise, they should be calling it raw eggs. And this does make a difference on if it's ready to eat and maybe the timing, time and temperature. So when you receive the questions, please be sure that you read carefully what type of egg they are asking questions about. And with milk, milk can be a liquid or dry product as well, should be grade A and following the regulatory compliance. What causes foodborne illness? Chemicals, for example. I want to jump ahead and just let you know the word incubation period means the time that you were exposed or that you ingested the pathogen and the time it has taken to develop symptoms. So chemicals tend to have the shortest incubation period. Often this can be poisonous mushrooms, shellfish, pesticides, metals, and again, it's a pretty rapid onset to illness. Foodborne illnesses that have longer incubation periods are often bacterial. It's the amount of bacteria that you have to take and it multiplies, so it takes a while to establish itself within you. So the infection is obviously, it takes a longer time. And intoxications usually have a shorter incubation period, and this occurs when there is a toxin or a poison, and again, the onset of symptoms is quick. So these are going through some of the definitions that I'm going to, of course, it froze. Okay. In environmental health and EPI, we break things down into kind of 5 major categories of risk factors that contribute to foodborne illnesses. One would be inappropriate holding temperatures for hot or cold holding, inappropriate cooking or inadequate cooking, was it left uncooked, raw, contaminated equipment, food of unsafe sources, and poor hygiene. And that's one reason we're going to get into employee hygiene later on. So the Food and Drug Administration has created the Food Code, and this is a model that safeguards public health and ensures that food is unalterated and of honest presentation when offered to the client. This model is adopted by local, state, and federal agencies and different groups that help provide the regulatory capacity for food establishments and services. One thing to note is that the different agencies and jurisdictions can adopt different parts of it or it in its entirety or certain segments. So sometimes even working interagency, there are some discrepancy because maybe one agency is not on the most current edition of the Food Code. So that is something always to take account when working together. But I've tried to cover the most universal and the most up-to-date for this presentation. When we look at the Food Code, we want to be sure you understand, and these were test questions for me, that they divide their items up into 3 important categories: priority items, priority foundation items, and core items. The priority items is a provision that is directly related to the elimination, prevention, and reduction of that harm that can cause food illness and injury. And often we're looking at quantifiable measures that show how to control the hazard, and that is more related to the actual cooking, the reheating, the cooling, and the hand washing. Those provisions or those items that will contribute directly to that. In the Food Code, those are all written with a superscript P. For priority foundation items, they apply to the support of facilitating or enabling one or more of those previous priority items. They require purposeful actions, equipment, or procedures. This is often specific training, infrastructure, necessary equipment, HACCP plans, or documentation. And in the code, it is a superscript PS. And then the core is basically anything that's not designated priority or priority foundation item. And this is usually general sanitation, operational controls, sanitation, standard operation procedures, equipment designs, and general maintenance. The next thing I'm going to go into are the different hazards, biological, chemical, and physical. When we talk about biological hazards, we break it down to bacteria, virus, and parasites. We can see this is kind of a lot, and some of the stuff is to help you guys later on review, that a lot of times our foodborne illnesses or illnesses that are attributed to foodborne, 30% are caused by bacteria, 3% by parasites, and most of them, of the known causes, are viruses. Amongst known causes, norovirus accounts for 67% of all the cases, 33% of hospitalizations, and 7% of deaths. As we can see, 81% of food illnesses are unknown, the agents, or what is causing it. Oftentimes, I think we've all been guilty of this, we'll get sick and won't go to the doctor, or if we go to the doctor, they just write up intoxication, food poisoning, and they don't send for labs. So a lot of times it's difficult to actually determine what caused illness if we don't have that lab. So about 81% of our foodborne illnesses do not have a known agent. So bacteria varies in shapes and sizes. About less than 1% of bacteria actually makes us ill. We coexist and have flora of bacteria with us. They come in rods, shapes, spheres, and spirals, and the size can vary, very small to a little bit larger rods, and we can see that that's one of the big issues of food sanitation. They're small enough to get into nooks and crannies where we wouldn't imagine, and we can see that something looks clean, or that 5-second rule that, oh, you pick something up. No, it's small, it's there, and it's present. So bacteria, to be able to grow, is going to require a couple of things. Food sources, the right temperature, the time. Again, bacteria have to establish itself. So once it's introduced to the environment, it has like a lag period that is kind of an exponential growth as it establishes itself, and then it plateaus off to be able to have the growth and death, and so it kind of plateaus off. But definitely that lag time is important, and that's why it takes a little bit to be able to become sick with a foodborne illness or an infection. It needs to have low acidity, relative water availability. So for the water activity, the pH of the food is very important, and also oxygen. For oxygen, we have two categories of anaerobic and anaerobic, which is, it does not need oxygen, and that's C. botulism is a perfect example. And then we have aerobic, which does require oxygen, and molds, yeast, and some bacteria fall into that category. Again, some need more moisture content to be able to grow. Yeast is a great example of this, needing high moisture for growth, while mold and several bacteria work fine in lower moisture. Spores is what happens when bacteria are often, it's a specific type of bacteria, but often it will be in a harsh environment or responding to an aging mature cell. And they develop these spores within their cells, and they become resistant to heat, low humidity, and other harsh conditions. The heat-resistant spores were actually used to help develop the time and temperature recommendations. They often can stay dormant for a long period of time, sometimes even decades, and favorable conditions later on help them germinate and grow new cells. Toxins, also in bacteria, can be formed by the bacteria. There are different types. The bacterial toxin that can be found in Staph aureus, B. cereus, or the botulism. And also we find natural toxins often present in marine that is an accumulation. For example, ciguaterotoxin is made by an algae and accumulated within fish as it grows and eats other fish. Shellfish toxins as well. So we want to make sure that, again, short time periods are often what it takes to be able to develop illness. And we keep going. Temperature dependency. So we have bacteria grow at all sorts of different temperatures. We definitely have, which we'll later on explore, the danger zone where most bacteria grow optimally. But we do have the outliers or the different extremes. That we have heat-loving bacteria, mesophilics, which grow in that moderate 68 to 113 degrees Fahrenheit. And then we have some very cold-loving bacteria that can grow less than 32 degrees, all the way down to 19 degrees Fahrenheit. So it's important just to know that temperature extremes, you can still have bacteria present. Things that influence when we're looking at a bacteria or a foodborne illness investigation, we definitely want to look at the pathogen. Again, was it a bacteria, a virus, a parasite, the dosing of that pathogen, the modes of transportation. Was it waterborne? Was it foodborne? Was it person to person first and then became foodborne because some ill person touched food? So all these things are taken into account. And the type of food, is it a food that is what we call ready to eat, that did not go through heat processing? Was it something that was packaged from a manufacturer? So the type of food does get looked at when you're doing outbreak investigation. And then also the type of food service. Are we talking about a restaurant that has a full kitchen and plenty of staff to kind of break up the different operations, or are we talking about a catering service that it was prepared somewhere else and transferred to another location, and you can see that there's an opportunity for temperature abuse if things aren't held at the proper temperatures. And then the host. We all are individual hosts and we all come with an array of problems and health. And so some of us may be more susceptible. So with less pathogen, some of us can have more adverse reactions. So for the dose, again, it's the quantity that is eaten of the organism or toxin. This is going to depend on how quickly you develop disease, and also if you develop, maybe you consume something that did have salmonella but had only a few organisms, so it wasn't enough to actually make you sick. Your GI was able to break down like through your own enzymes and things, and it did not cause illness. But we call an infectious dose is how much of that organism is needed to cause illness. So norovirus, for example, only needs 10 to 100 viral particles to cause illness in someone. Staph aureus, you need a greater amount. You need about 100,000 colonies to become ill. Vibrio vulnificus, which is often with shellfish, filter feeder, stuff that comes out of the water, only needs 1 to 10 organisms. So it's something that takes very little to make people sick. And again, infections can manifest themselves in different ways in the host. Some people can have asymptomatic, where you do not have symptoms. We've heard that a lot with COVID now. We've had people that are asymptomatic, so they weren't showing any signs of disease. Or you can have overt or clinical, where you have a manifestation of, are you having nausea, vomiting, headaches, diarrhea? It can be a different range of moderate to severe. So sometimes you'll have two individuals that ate and both got sick. One may end up in the hospital versus the other one having mild symptoms. Incubation periods, again, the amount of time it takes to become ill after having been exposed to the pathogen. For Staph aureus, which is bacteria, it ranges from 30 minutes to 8 hours, and on average 2 to 4 hours. For salmonella, again, it's a hourly range from 2 to 72 hours. On average, you get 12 to 36. Campylobacter is 1 to 10 days. On average, 2 to 5 is what we're seeing. For viral pathogens, we see that norovirus usually takes 10 to up to 50 hours, but most people, it's kind of called the 24-hour bug because most people will develop symptoms within that 24 or 48-hour period. And hepatitis A, which is one of the longer incubation periods, is 15 to 50 days that from the time you become exposed to developing disease. And because of hepatitis A is that we have the 90-day keeping of our oyster tags or shellfish, because that is 2 full incubation periods of what hepatitis A would be. So we want to be sure that most people develop symptoms within 28 to 30 days, and Florida, along with several states, has been experiencing an outbreak. So many of you actually are probably familiar with the hepatitis A virus. Pathogens or incubation periods for parasites. So Cyclospora, we don't really know how far out it can be, but most people will show symptoms within 7 days. Cryptosporidium is 1 to 12 days, but on average 7 days. And we have this slide that is kind of to help us if we don't have a lab that actually goes. Okay. I'm seeing something about slides not going along with, I closed my chat book, so hold on a second. Are we on the belly button rule?
Yes.
Okay, sorry. So the belly button rule is something that we use when we don't have a lab report. Again, several people either didn't make it to the doctor on time or to get a lab or stool sample done, or simply, we find out a little bit later and aren't able to encourage that. So we want to say that above your belly button, you're going to have symptoms of nausea, stomach pain, and this is often, and vomiting. This is often an intoxication, which again, it will be bacterial, but often this rapid onset is, you often think of Staph aureus, B. cereus, maybe chemicals, toxin. Again, it's more of an intoxication. Usually symptoms that are from the belly button down, you have abdominal cramps, diarrhea, fever is often signs of an infection. Onsets can be longer, from 1 to 50 days. We will think quickly of norovirus, salmonella, and campylobacter. So again, it's not precise science, but it's something that's a guideline that we help when we don't have a lab to go by. All right. Infections, I did cover them already, but I just wanted to give you guys a little bit more information. It's that you have to ingest it. It multiplies inside your gastrointestinal tract, and then that's when you start developing symptoms: nausea, vomiting, diarrhea. Intoxications are more rapid, and the toxins can come either already pre-made in the food or later on in your digestive tract. After ingesting, you can have toxin release, and that's one thing that E. coli is the Shiga toxin later on in your intestinal tract. Fungi is a category that I won't go too deep into, but I do want to let you know the different groups: that yeast, molds, mushrooms. Again, mushrooms can be mushroom poisoning and toxins there. Yeast often are what cause spoilage of food, and there are some the terminology. Viruses are cells, or they actually are a pathogen that cannot live on its own. It requires another cell to kind of be its factory. So it's going to need living cells to be able to reproduce. This is often received viruses with poor personal hygiene, and we saw this with hepatitis A. We were seeing an increase in, especially like the homeless community, and drug use because of the low or the unavailability to maintain the hygiene. So again, it's improper hand washing after using toilets, sneezing, after blowing nose or touching face. It's often, we'll see many viruses are oral fecal. So they can exist on utensils and surfaces for a long period of time, and often thrive in polluted waters. So that's something that we can see as well after large storm systems, et cetera. As that sewer water mixes in with rainwater, we can see the presence of viruses. They are destroyed when cooking and are often implemented with ready-to-eat foods, so foods that do not require additional heating after they've been put together. So salads, sandwiches, fruits, raw shellfish are all places that viruses have been, often associated with. Norovirus is the most common food illness virus nationwide, and we are seeing that also, as I mentioned earlier, hepatitis has the longest incubation period for 1 to 15 days. Again, remember those shellfish tags of 90 days because we're looking out for other pathogens as well, but mainly the length of 90 days is because of Hep A. And so for parasites, this is an organism that lives within another organism. It requires a host as well. Oftentimes we ingest food that has not been properly cooked to temperature. It can also be present in drinking water. So Giardia, we often see associated with infected food workers and contaminated water. Cryptosporidium, oftentimes livestock. We've seen several cases too of cattle with diarrhea and people who are helping nurse them back will later on develop cryptosporidium. And so those are just to name a few. The prevention, again, is cooking foods thoroughly and having safe water supplies. Chemical hazards, we have excess flavorings, what sometimes are cleaning and sanitation components, pesticides, heavy metals. These are all things that can be present, causing that rapid onset or that short incubation of illness. We can often make sure that we're storing things appropriately, and also making sure that food is acidified will help reduce some of these issues. Physical hazards often are foreign objects, which can cause serious injury and unfortunately litigation as well. That will be the Band-Aid that fell in, paint chips from a roof or a ceiling that's not smooth and clean, dust from different places, fingernails, which is one of the reasons too we need to be sure when inspecting if we detect long nails that we make sure to signal to people. I think that that's something that keeps getting kind of swept under the rug. Broken glass, so we can have drinking glasses that might break nearby, light bulbs that can fall in, hair, jewelry. So these are all bone fragments, all different objects that can be found in, become a physical hazard. So I'm going to go into the HACCP, which is for prevention of food contamination. It's a hazard analysis critical control point, HACCP, and the prevention is to monitor. It's a prevention-based food safety monitoring system. It helps identify where a product has risks and how to address it. It helps determine the steps necessary to control that risk. So we have a critical control point, and this is where the potential hazard is in the process. And once it's controlled, you can eliminate or reduce the hazard or the risk of food-borne illness. So to develop and implement a HACCP plan, you analyze and monitor the preparation methods, and you're able to make sure it's very standardized and keeping records. This allows for a comprehensive view of the preparation, and to be sure that, again, we're addressing known risk points. Not everything requires a HACCP plan. So some facilities you go to will not have them, but definitely HACCP, if I recall correctly, the story was developed by Pillsbury when they were making food for the astronauts. So that was the original cause of it and use for it, and then later on was adopted into the rest of industry. The 7 principles we want to look at, again, we're taking and analyzing the hazards, identifying those places of potential risk or where there's a known risk in that step, being sure that we can prevent it and having a critical measure at that control point, establishing a procedure to monitor those critical control points. Once those points are not reached, we want to be sure we have a corrective action established, establish a procedure to verify that the system is working. And then once we have it set up, you want to be sure you're keeping proper documentation, record keeping of each step. What was the monitoring, what was the correction done if of those monitoring points were not reached. So I'm going over this pretty quick with due to time, but I do want to encourage you to look at this section because there will be questions on HACCP. Again, not everything requires a HACCP, and some states and local jurisdictions do not necessarily have them implemented. This is different from what is used and what most of us environmental health are aware of is the traditional inspection that does focus on the structural maintenance and cleaning of the facility and the handling of food. But HACCP is definitely a way to prevent food contamination when there is known risks in the process. Now we're going to move on to time and temperature. We use the FDA food code to help establish what safety recommendations for time and temperature. This gives us cooking, reheating, storage temperatures. Again, it depends on if your state or jurisdiction adopted the whole food code or if they have the updated food code. The state of Florida, for example, has one food code. I worked in Puerto Rico, and they adopt the year it comes out to its entirety, the food code. So every jurisdiction can vary. The time temperature control for safety, which is TCS, formerly was potentially hazardous foods. So sometimes in notes you'll see PHF, and that is just the foods that require time temperature control for safety. These foods, the time and temperature control helps limit the pathogen growth or toxin formation. So that is one reason we want to be sure we're taking time and temperature into account. There is a product assessment required for food, and this is any food that's capable of having rapid bacterial growth that can lead to illness. They have a pH of 0.6 or greater or above, and a water activity greater than 0.85. Examples of these foods would be milk products, eggs, meat, poultry, fish, shellfish, cut produce such as tomatoes and cantaloupes and melons. You have seed sprouts, unpasteurized juices, cut leafy greens, and garlic and oil mixtures. Foods that are not considered TCS or that do not have time temperature control for safety would be things that have a pH of 4.6 or below and water activity less than 0.85. Example of this would be cooled at air-cooled hot hard-boiled eggs with a shell intact, and also food that is packaged that has proof that or evidence that they do not grow pathogens. For time and temperature, I put together a couple of important temperatures that we have -4 degrees Fahrenheit for 7 days. We'll do parasite destruction for the raw fish that will be used for sushi or ready to eat fish. 0 degrees Fahrenheit is the definition of frozen. We have 41 degrees Fahrenheit or below is considered cold holding. And then 135 or above is considered hot holding. That danger zone is anything that is below 141 to 135. That is optimal range for bacterial growth. So we want to be sure that we are taking into account when foods are crossing that danger zone. 145 degrees for 15 seconds is the temperature that you would have cooked eggs, fish, pork, and beef. 155 degrees Fahrenheit for 15 seconds is where you would have all of your kind of mixed meats. And 165 degrees Fahrenheit for 15 seconds is where we have all of our reheated foods that are time temperature control for safety. Poultry, stuffed meats, so anything like a meatloaf, anything that is a mixture, like a casserole type thing, anything like that does require a 165 degrees Fahrenheit heating. And anything in the microwave, all foods that are microwaved should be taken up to 165 degrees Fahrenheit. This is a lot of the same stuff, just kind of set up on the thermometer so you can visualize it better. Again, the destruction of parasite for sushi is -4 degrees for 7 days, or -31 degrees Fahrenheit. Different methods that we would need to be aware of what temperature is for thawing, for example. Thawing, these are the different methods that are appropriate to thaw in the refrigeration. So like under refrigeration, it needs to be 41 degrees or less. So oftentimes you'll put a chicken in the freezer from the freezer to the fridge and let it defrost there. We can do running under cold water, but the temperature should not increase more than 70 degrees. It can also be inside the cooking process. That's supposed to be a separate bullet, or in the microwave. If you thaw in the microwave, it has to go directly into cooking. You cannot cold hold it. You're supposed to defrost the microwave and continue the cooking process. Flocking is a term that sometimes does come up, and that is where you're gradually warming food from frozen to unfrozen. This should be done under refrigeration. Cooling, we have different kinds of coolings, and this is where most of our foodborne illnesses, I think the number is like 46% of the foodborne illnesses end up having the temperature issue happen during cooling. Ambient cooling is when you have something such as that is prepared at room temperature, such as a salad. It can cool from room temperature. You have 4 hours to achieve 41 degrees for ambient food. Food that is cooked or hot should be cooled within 2 hours from 135 to 70 degrees. And then you have another 4 hours to reach 41 degrees. So you have a total of 6 hours to reach from 135 to 41 degrees. But it is crucial that you make 70 within 2 hours, the first 2 hours of it. Otherwise, you can, if you're still within the 2 hours and you're not working it down fast enough, you can reheat and start over. But that 2 hours is the time you need for the 70 degrees. Methods that you could use to facilitate cooling would be using shallow pans, smaller portions, rapid cooling or air blast, using stirring or ice paddles, containers that help transfer or take out heat. Sometimes having like a water bath is one of those containers that would help transfer the heat. And adding ice, sometimes you can make a more condensed soup, and ice, which later on the water becomes an ingredient in the recipe. For one thing that are kind of exceptions or outliers, raw eggs should be kept at 45 degree or below during transport, and then at the retail holding can be at a maximum of 45 degrees Fahrenheit. Milk and shells can be received at 145 degree or 50 degrees respectively for the molluscan shell, but must be brought down to 41 degrees within 4 hours. So we can receive things at a little bit, milk and molluscan shells at a higher temperature, but must be cooled in the end to 141. Food sampling, it's just a simple slide to let you know that there are some routine places that we are looking for microbes. Listeria, for example, FDA does quite a bit of environmental sampling. Oftentimes we're looking at soft-serve dessert machines, ground beef, potable water. These are all routine places that we do environmental sampling. But within outbreak investigations, we've found kind of a combination where certain pathogens are often paired or linked to certain food groups. So E. coli 0157H7 is often found in ground beef, alfalfa sprouts, water, unpasteurized apple juice, milk, and now we can add leafy greens. Norovirus is often ice, shellfish, because again, they're filter feeders, and we can have norovirus. I just want to make sure that comment wasn't for me right now. Salmonella, we can find in cantaloupes, tomatoes, freshly squeezed orange juice, alfalfa sprouts. And so just you can see cyclospora, for example, we just had a recall recently of basil. There are certain foods that are often paired with those pathogens. For training, we want to be sure that food workers receive proper training on hand washing, food precautions, policies, and procedures, and you should have a certified food protection manager with an accredited program if you have 4 or more employees. Often the issues that we see is that we have high turnover, and food establishments need to be sure they have a copy of what are the trainings that they are giving. For employee hygiene, we want to be looking at hand washing. It has to be done at a specific sink. We have a hand washing sink that is exclusively for that use. It should have a duration of no less than 20 seconds with hot water. And you need to be sure that they're washing their hands before preparing meals, and also you should wash your hands before eating a meal. Hand washing should be done after you use the restroom or change diapers, handle uncooked food, blowing of nose, coughing or sneezing, playing with pets, or even if there's any kind of animal at the facility, or attending to anyone that is sick or injured. We also want to be sure that employees are washing their hands between soiled equipment use or utensils during food preps, or switching from raw to ready-to-eat foods. So hand washing is vital during all of the above. The use of hand sanitizers must be a hand sanitizer that meets specifications from FDA and should only be applied to clean hands. So soiled hands with hand sanitizers is a no-go. If an employee is diagnosed with an illness, such as there are now 2 salmonellas, Salmonella typhi and just Salmonella species, Shigella, E. coli, hepatitis A, or norovirus, those illnesses must be reported to the person in charge, and that person in charge should report it to the health department. One thing that is often used to help remind us of these, what now is Big 6 because of the 2 salmonellas, is send sick employees home now. Each word should represent a pathogen, and we just double up the salmonellas, Salmonella typhi and Salmonella species. Also, if someone has symptoms or an infection or illness that are caused by diarrhea, fever, vomiting, jaundice, sore throat with fever, or a lesion containing pus, they should not be working. So we want to make sure that that employees are well aware of the symptoms and the Big 5, because employees that are diagnosed with Big 5 or symptoms should be excluded. To exclude is to prevent the person from working or entering into the food establishment, or they can be restricted depending on the illness and the situation, but exclusion should be what happens when they are symptomatic or have one of the Big 6. Sometimes we see that due to pay, little bit of sick or lack of sick leave, or just management and owner indifference, we may see these as barriers to exclusion, but the correct thing is to make sure that the employee is not working or in the facility when they have Big 6 or symptomatic. For policies and procedures, drinking, smoking, and the use of tobacco should only be used in designated areas and should have hand washing after each one. Employees should use only closed lids containers in designated areas to help prevent the contamination of their hands in the containers, and should not be in food prep areas. Unsanitary practices are wiping hands on soiled aprons, wearing excessive jewelry, long painted fingernails, wiping sweat, long hair restraints, and storage of personal items near food prep areas. Different ways of contamination, employee should not be touching ready-to-eat foods with their bare hands. So they should not be exposed or touching bare hands any of the ready-to-eat items. There should be a use of utensils to engage food that is not going to be heated up anymore or is ready to eat by the customer. They should also single glove use for tasks. They are single glove use and should be discarded and hand washed between. Ice is something that can be used to cool down food, but if it is used for something else, if you're cooling something else down, then that ice cannot be used. Ice is considered a food, so sometimes we have bartenders that are like, oh, but I don't handle food. Food and drinks are considered food. Again, sorry, trying to zip through this. For cleaning, we have utensils, surfaces, and cleaning in place of large items. We make sure we do this between the different uses of raw foods and raw animal meats because chicken has a different cooking temperature to pork. We want to be sure that as we change out the raw food, we are cleaning and disinfecting and sanitizing between use. Each time that we change from raw to ready to eat, again, all of the utensil surfaces should be cleaned and sanitized. Between the use of raw food and vegetables as well, and any time that a contamination may have occurred, we should have cleaning. Dishwashing, we should have the 3-compartment sink that will have wash, rinse, and sanitize. And then in the air, at the end, it should be air drying. The different sanitizers that are approved for food productions are chlorine, iodine, and ammonia, coronary ammonia. Our thermometers or our temperature measuring devices should be accurate to a plus or minus 2 degrees Fahrenheit. And when sanitizing, if we are sanitizing manually, hot water should be 171 degrees Fahrenheit for 30 minutes, or 30 seconds, I'm sorry. If we're using a mechanical hand washing or mechanical machine, a stationary rack should achieve a temperature of 165 degrees Fahrenheit. If not, the manifold should be reaching 195. And all other machines should be sure that you're reaching a maximum temperature of 180 degrees Fahrenheit. All right, sponges. We should not be using sponges to come in contact with clean or sanitized food contact surfaces. The only woods that should be in use are hard maple or equivalents of hard closed grain. Those could be cutting boards, cutting blocks, baker tables, utensils such as the rolling pins, donut dowels, some salad bowls, chopsticks, but again, it has to be a closed grain wood. Multi-use contact surface areas should be smooth, free of any breaks, cracks, chips, dips, pivots. It should be smooth and clean and easy to clean. Those surfaces should be cleaned at minimum throughout the day, every 4 hours. And same thing for when we have something that needs a large equipment that should be cleaned in place. It needs to be sure that it is smooth and easy to clean. Oftentimes, facilities are supposed to present detailed plans and plan reviews to environmental health, and so we need to be sure that we have the equipment that they will be needing, the layout to scale, make sure that all construction details of where is the hand sink going to go, the materials used that should be smooth and easy to clean, and the floor is non-porous. Same thing with the walls and ceilings. They need to be smooth and easy to clean. There is regulation within the food code as well that we need to be monitoring. Again, are we making sure that it's smooth and easy to clean for floors, ceilings, and walls? The ventilation system, want to make sure it's appropriate potable water, that there is appropriate sewage disposal, that the garbage is on top of a non-permeable like concrete flab, that it's got its plug-in, and that it's got a lid that can be tightly closing. And we want to make sure that all of the equipment is following the guidelines of the NSFI or the UL. For receiving, we want to make sure that we have the right sources, that we're able to, in Florida, we do have some cottage foods, but we do not, things that are appropriate sources should be no home canning, no home preparation. It needs to be a separate certified kitchen. Inspections of food products should happen as they arrive. They should be checking for damaged, spoiled, or contaminated products, and this should be done frequently. Upon arriving, they should be verifying the original container, even the transport vehicle when they're dropping off. Like if it was a refrigerated truck, we want to make sure it's in good conditions. If you're seeing excessive condensation leaking, ask about it. Have your facilities or establishments ask about it. Are they seeing signs of mud, dirt, rodent, and also are time and temperature control for safety products being temped upon arrival. Products should be rejected if they're damaged, spoiled, or contaminated, and need to verify that they bear the inspection label or seal of approval, such as SDA meats and eggs and milk, and make sure your tags are on your shellfish, and that labels are properly on cans and that aren't having dents, etc. When ways to monitor once food's received, you want to make sure proper temperature, freshness, and safety is maintained. There needs to be a first in, first out order. Leftovers need to be properly cooled, packaged, and labeled and stored. Also, this labeling is to ensure that things are discarded appropriately. So something that's open more than 24 hours should have a date or a label of a date. Storing things, you need to be sure that it's 6 inches off the floor, unless it's got specific packaging that is a working container, but really 6 inches off the floor is the rule. Really quick on plumbing and lighting, we want to be sure that backflow prevention and air gap should be between the source of water and the rim. It needs to be twice the diameter of the line going into the equipment. So this should be no less than 1 centimeter, or 1 inch, 25 millimeters. Other terms that I'm not going to go into due to time, I want to make sure that you guys look up cross connection, back siphoning, backflow, and air gap I have included here. Lighting should be 20 feet candle for the self-service areas or inside equipment is the minimum, and then 50 feet candles for food prep area. For pest control, the pests we're concerned about, roaches, ants, beetles, you guys can read the list. We want to be sure that they're keeping out that there's air curtains to help avoid flying insects, proper screening when necessary, and looking for possible grease marks on the floorboards to identify rodent moving. It's always a potential risk at a facility, so we don't ever want to underestimate it. Basic sanitation is the most effective method of pest control. If we don't leave food out and we clean surfaces correctly, then there's less appeal for the ants, et cetera, to come out. We want to make sure that it is licensed pest control agent that are coming to do the pest control. It should never be in direct food prep area to avoid possible contamination, and receptacles both inside and outside should be covered. And real quick for the Epi section, you guys did get to hear some Epi stuff at the beginning, but we want to make sure that the 10 steps of an Epi outbreak investigation is that we identify who's on the team and what are the resources. We establish if there's an outbreak, to confirm, sometimes you'll have, there's three 3 kids in my kids' preschool who have salmonella. And you're like, they're diagnosed with salmonella, and once you call and follow up, you might have 3 gastrointestinal situations, but nobody actually has a diagnosis. So we'd still look into that, but we want to make sure that we confirm the existence of an outbreak. We verify the diagnosis. It can be probable or confirmed. Again, sometimes we don't have lab criteria to go off of, so sometimes we use that belly button rule to help try to pinpoint what are potential pathogens, construct a case definition of time, person, place, find a way to develop a line list or do systematic case finding. We perform the descriptive epi, so we're trying to describe who and what and where, and again, time, person, place. Within that, to develop the hypothesis: was it a foodborne? Was it a person-to-person? What's the situation? And then sometimes that requires additional further studies. We want to implement control measures, like what are the things that can be done to reduce the risk and break the transmission, and then communicate the findings. That goes as simple as making sure that we're communicating with the ill people and the facility, writing a report, also sharing that information with CDC at a national level. These are all ways that we're communicating the findings so that we can learn how to improve outbreak investigations and just food safety in general, and then maintain surveillance. Again, some of the things that we look at when outbreak, we're now seeing more genome sequence, so genetic structure or whole genome sequence, trying to link up not only environmental samples but clinical samples to see, again, if we're having more people, more female, more male, age groups, things that will help us identify the affected group and causes. Was it more children? Was it more within a specific occupational group that will help us develop the story and find out what is the cause? Was there social activity? Was everyone a participant of a wedding or, a Christmas party or something that everyone got sick at? So these are all things that we look to answer. One thing real quick that often will affect especially when it comes to egg questions, high-risk individuals. So I want to be sure that somewhere I named who those were: infant, children, pregnant women, elderly. So basically the two extremes of ages, and then pregnant women and immunocompromised individuals are all considered high-risk groups. And that will be really important on the use of pasteurized eggs and pasteurized juices, and making sure that we're not increasing their risk by using high-risk items. Kind of a recap of some epi terms. Exposure is when you come into a contact with a potential risk factor. That could be a behavior or attribute. So if you ate something, you're exposed to it. If you were in contact with another sick person, these are all risk factors that could have been your exposure. If you drank or ate something where did you shower at a hotel and later on develop Legionella, your exposure would have been the hotel shower. So outcomes is disease or health-related condition. Incubation is the period of time it takes from the exposure to developing symptoms or disease. Incidence is the new number of cases of disease in a population at a particular time period. Prevalence is the total number of people ill with the disease, so that will be old and new cases. So incidence is only new cases. Prevalence is the old and new cases of that disease in the population. Attack rate is the number of people who got sick divided by the total of those exposed, or the total number of people who got sick over or not sick over unexposed, and then you multiply that by 100 and gives you a percent. So those are kind of the bigger chunk things, and just good luck. My connections, or Michael will be able to put up my stuff so that if there's anything else I can help clarify. I try to put highlight stuff because it's a lot of material for the review. And let me know any questions.
All right, thank you very much. So this will conclude our RS review for today. All of these presentations will be available online. Give me a couple days to post them up by the end of the weekend. They'll all be on the website. I also wanted to announce really quick that we'll be having 2 more reviews. They're going to be shorter, and they're going to be single subjects. So keep an eye out on your email box. But if you want to write the dates down now, January 15th and January 29th will be at 10 a.m. There'll be about an hour-and-a-half long classes. The 15th will be on indoor air quality, and that'll be put on by Tim Wallace from the Florida Department of Health. And then on the 29th, we are going to be doing a more in-depth for food inspections. And that is going to be from, let me give you her name correctly, Tracy Mitchelson. She is the manager of restaurant food safety for McDonald's Corporation. So again, the January 15th and January 29th, we will have 2 more presentations, so be on the lookout for those. And with that, thank you all very much for attending. If you did not sign on with your full name participants list, please email info@fihad.org so I can get you out your certificate and check you in on your attendance. The certificates will be mailed next week, so I'll wait for those to come in next week as well. If you have any questions, feel free to email us. We'll get the answers for you from the presenters. And with that, thank you all for attending. Have a great weekend and a very Merry Christmas.